This video is about the promotional session of our college. Now, I would like to invite our co-convener of this program, Dr. J. Pavan Sai sir, to join with us. Now, I would like to invite our convener of this program, Dr. CHVS Parmeshwar Rao sir, and also principal of the Vikas College of Engineering and Technology. Now, I would like to invite our Dean of Academics, Dr. Sevak Rajan sir, to join with us. Now, I would like to invite our Executive Director, Ms. Kirti Naredla ma'am, to join with us. Thank you so much for joining with us, our respected dignitaries. To begin this auspicious program, now I request our honored dignitaries, Mr. J. Pavansai sir and Dr. CHVS Parameshwar Rao sir and Dr. Sevagarajan sir and Ms. Kirti Naredla ma'am to proceed with the lighting of the ceremonial lamp symbolizing knowledge, hope, and sustainable progress.
गणनायकाय गणदैवताय गणाध्यक्षाय धीमहि गुणशरीराय गुणमण्डिताय गुणेशानाय धीमहि गुणातीताय गुणाधीशाय गुणप्रविष्टाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय भालचन्द्राय श्रीगणेशाय धीमहि
Hello. Sir.
गानचतुराय गानप्राणाय गानान्तरात्मने गानोत्सुकाय गानमत्ताय गानोत्सुकमनसे गुरुपूजिताय गुरुदैवताय गुरुकुलस्थायिने गुरुविक्रमाय गुह्यप्रवराय गुरवे गुणगुरवे गुरुदैत्यकलक्षेत्रे गुरुधर्मसताराध्याय गुरुपुत्रपरित्रात्रे गुरुपाखण्डखण्डकाय.
I would like to invite our co-convener, Mr. Dr. J. Pavansai sir, to address us about the program overview.
अरे आवाज ये ना मुझे विक्रम करता है ना कि पुरानी चीजें की समस्या आ रही है विक्रम चले ले ठीक चले लेकिन अब
Yeah, please mute all of you. A warm good evening, Manola. Respected chief guest, dignitaries, resource person, esteemed colleagues, and dear participants, it gives me great pleasure to welcome you all to the AICTE ATAL sponsored Faculty Development Program 2026 with a theme of Next Generation Technologies for Energy Efficiency and Sustainable Innovation. Total 600 members have joined entire India from different colleges, universities, and different research organizations. This FDP clearly shows its importance. We are privileged to have large number of participants representing from various engineering colleges, autonomous institutions, and universities from different regions coming together with a shared goal of learning, innovation, and academic growth. Today, energy and sustainability are not just technical topics, there are responsibilities. As a educator and researchers, we shape the mindset of the future engineers who will design systems that are efficiently, intelligently, and environmentally responsible. This FDP is a step towards strengthening that responsibilities by exploring the different types of new technologies existing in the uh, sustainable development energy techniques. For the next few days, this program will be offer valuable insights with different types of technologies related to the sustainable development. I sincerely thanks AICTE and ATAL Academy for their continuous supports empowering faculty across the nation. I also appreciate the dedicated efforts of our participants and volunteers for making this program possible, effective way to conduct from the coming next 1 week. I'm confidently telling that this FDP will be inspiring new ideas and innovations of the faculty members. Once again, a warm welcome to all of you, wishing everyone for participating this particular ATAL FDP program for coming next 1 week. Thank you, one and all. No, next. Currently, okay.
Thank you, sir, for your valuable words. Now, I would like to invite our convener, Dr. CHVS Parmeshwar Rao, sir, the principal of Vikas College of Engineering and Technology, to address us.
Sir, meet the end, sir.
Thank you for inviting me. This is Dr. Parmeshwar Rao, Principal of Vikas College of Engineering and Technology and convener of this ATAL FDP on next generation technologies for energy efficiency and sustainable innovations. I welcome all the dignitaries, especially our beloved chairman, Professor Narsireddy sir, Executive Director, Ms. Kirti, our Dean Academics, Dr. Sevagarajan, Dr. Pawan Sai, co-convener, other faculty members from all over the country, and also the resource persons delivering the talk to this august gathering in this evening for the ATAL FDP on the most required topic, the topic of the present time, energy efficiency and also sustainable innovations. All my dear learned friends, all of you know what for these FDP program, FDPs. Unless we the faculty being developed from time to time, we cannot deliver good talks and good subject to the next generation. So being a faculty, we are learners till retirement. But the student can be only for 4 years or 2 years like that. So all the time, whatever the technology we have learned during our studies may not be sufficient, and we have to get upgraded from time to time. And we are thankful to AICTE for providing funds and platforms to conduct such a fabulous programs. I'm happy and proud to be a part of this AICTE ATAL FDPs and other FDPs also since the past 15 years. And more than 10 FDPs I got sanctioned by AICTE so far and conducted successfully by making our learned friends, faculty of various organizations, pan-India, enriched their knowledge and also being transferred to the next generation. I also served as an adjunct professor selected by AICTE with a grant of 6 lakhs few years ago. I feel very happy for the good response from my dear learned friends to participate in this FDP. More than 600 registrations and present 215 people have joined right now. And many inquiries have come up from all over the country to allow them to join even in the last 2 days also. This shows the importance of the faculty development program topic especially and the value of the beloved speakers. I'm thankful to all the 13 speakers from prestigious organizations from India and abroad. We, the teachers or faculty, must upgrade our knowledge and skill from time to time as the technology is getting developed very fast and students' IQ is also going up. So in order to sustain in the teaching profession and transfer of technology or knowledge, these sort of FDPs are very much essential. Once again, I'm thankful for the AICTE to sanction us to conduct such a program. And I'm confident about our faculty to come out with this sort of topics to be conducted and the interest being shown by the participants. I hope this will become a good platform for proving ourselves in the area of energy efficiency and sustainable innovations. And also I wish all the participants to enjoy and enrich their knowledge during this week time. And also I request all of the participants to transfer this knowledge to the next generation. Thank you one and all. Enjoy the new technologies being delivered by the speakers. Thank you once.
Thank you, sir. Thank you for your valuable words. Now I would like to invite the academic dean of Mr. Dr. Sevagarajan sir to address us.
A very warm good evening to all the participants. I first of all thank my the management for conducting this workshop and our beloved chairman Dr. Narsirity sir, our executive director Ms. Kirti madam, and the AICTE for granting us the funds for conducting this FDP on next generation technology for energy efficiency and sustainable innovations. And also welcome all the participants for attending this event. Today, the challenge of energy efficiency and sustainability is one of the most important issues that is facing our world. As energy demand grows, the next generation energy technologies are reshaping how we produce, manage, consume, and utilize the energy in a smarter way and in cleaner ways. Advanced solutions such as smart grids, we are able to save a lot of power and things. And now combined with artificial intelligence, it allows the energy systems to respond in real-time scenario. And now reducing with the help of artificial intelligence, it helps us reducing the wastage of energy and improving the reliability. So many breakthroughs have been happened in terms of energy storage and including the advanced batteries, rechargeable batteries that are developing, and ensuring that the renewable energy sources like solar and wind energy can provide power even when the sun is not shining. And at the same time, innovations such as the green and hydrogen technology and carbon capture are helping us decarbonizing heavy industries, transportations, and manufacturing sectors that were once difficult to transition. And beyond the energy production, also sustainable innovations is transforming buildings, cities, and industries. Smart materials, energy efficient buildings, and digital technologies reduce the consumption while maintaining comfort and productivity. Together, this advancement support a more resilient economy, lower emissions, and responsible usage of the available resources. In embracing this next generation technology, we are not only addressing the climate change, we are creating a future that is efficient. We are creating an efficient, innovative, and sustainability for generations to come. And I hope the next few days you will have a great knowledge and the takeaways from these workshops by attending the lectures provided by 13 eminent academicians and from industrialists. I hope all the best and have good time with this conference. Thank you.
Thank you so much, sir, for your valuable words. Now, I would like to invite the executive, the executive director of Vikas College of Engineering and Technology, Ms. Kirti Naredla ma'am, to address us.
Hello, all. Firstly, a warm welcome to our esteemed faculty members joining from different organizations and our very strong keynote speakers who are going to share their experience and knowledge on a very intriguing topic, ATAL FDP, on next gen technologies for energy efficiency and sustainable innovation. I'm very glad to share this. The union budget that was announced yesterday also focuses on certain niche areas that perfectly aligns with this FDP. The union budget has decided to fund national green hydrogen mission, in fact double the funding to 6 billion, and also focus on developing the rare earth corridors, which is going to make gathering the critical minerals for EV vehicles and solar panels even more efficient. At the same time, 20,000 crore roadmap is being laid for the CCUS and also the development of small modular nuclear reactors as part of the plan. So all of these different areas align with the current FDP's topic, and I'm very glad to have 600 plus registrations of faculty members, which shows your zeal and enthusiasm to take this country's R&D to next level. As a result, improve the quality of education in alignment with Viksit Bharat 2047. And I would like to share my heartfelt thanks to the line of speakers that have agreed to come on board. We have esteemed speakers from reputed organizations like ISRO and DST. So thank you so much, Anil Garu from ISRO, Dr. Anil Garu from ISRO, and Dr. PK Jain Garu from DST for agreeing to be part of this FDP, as well as we have industry leaders from Zindal, Mahakrish, and tech organizations, and academicians from top-notch universities, IITs and NITs are also taking active part in conducting this FDP, so that their knowledge and experience is going to make a very meaningful impact on all the faculty members who are joining this FDP. As a result, you will be able to take this back to your institutions, improve the R&D as well as the quality of education. I also congratulate our team here at Vikas College of Engineering and Technology, convener Dr. Parmeshwara Garu and co-convener Dr. Pavan Sai sir, for putting this together and successfully starting the FDP. So I'm really looking forward to hear all the good takeaways from everybody joining the FDP, from faculty to the line of speakers. Thank you so much for giving Vikas this opportunity. Thank the Ministry of Education and AICTE for creating a platform like this, ATAL, to organize this FDP in such an impactful manner. So thank you so much.
Thank you, ma'am, for your presence. Now, let us see another glimpse of Vikas College of Engineering and Technology. A request, Raga Kirtika ma'am, please be muted.
Hello.
Sir, you're audible, sir.
Yeah, thank you.
I request all the faculty members, please be muted. This is the high time to start the presentation by Dr. V. Anil Kumar Garu, holds a BTech Metallurgical Engineering from MGIT Hyderabad in 2002 and an MTech in Metallurgy from IIT Kanpur in 2003. He began his career at Hindustan Aeronautics Limited, Bangalore, and later joined Vikram Sarabhai Space Center, Thiruvananthapuram in 2005. For the past 2 decades, he has served the materials and mechanical entity at VSSC and currently holds the position of Scientist SG and Deputy General Manager. He completed his PhD in Metallurgical Engineering from IIT Bombay in 2020. Dr. Anil Kumar is a specialist in the development and production of titanium alloys, super alloys, special purpose alloys, and additively manufacture components for space applications. He is also leading the establishment of ISRO's Center of Excellence in Additive Manufacturing for Space Applications, demonstrating his pivotal role in advancing metal additive manufacturing capabilities for the India space program. Among his notable honors are the ISRO Young Scientist Merit Award in 2013, SAME Prodhyogika Award in 2018, Knight and Rastogi Award from IIT Bombay for PhD Excellence in from 2019 to 2021, and Additive Manufacturing Society of India Award in 2022, and I Am Hindustan Zinc Gold Medal in 2025. With over 90 international journal publications, 50 conference presentations, 3 book chapters, and several invited and keynote talks, he is widely recognized for his contributions in non-ferrous metallurgy and metal additive manufacturing. Now, I would like to invite Mr. Dr. V. Anil Kumar, sir, to start the presentation.
Yeah, thank you for the nice introduction. Hope I'm audible.
Yes, sir.
Yes, sir, you are audible.
Yes, sir. Audible,
Sir, your voice is audible.
Is my presentation also visible now?
Yes, sir, clearly
Yes,
visible.
yes, sir.
Okay, yeah. So once again, good evening to all. So I think you have chosen a right topic, which is apt for this current period in which India is going through. That is next generation technologies for energy efficiency and sustainable innovation. So as a part of that, I thought I can talk on additive manufacturing, which is again a sustainable and innovative technology. And I would be specifically talking on metal additive manufacturing for space applications with focus on sustainability and innovations. So yeah. Yeah, if you look at the UN Sustainable Development Goals, these are the different 17 different sustainable development goals that were laid down by United Nations. And again, if you see the focus which I am going to dwell upon, very two specific sustainable development goals are industry, innovation and infrastructure, and also responsible consumption and production. So when you talk about these two sustainable goals, additive manufacturing fits both of them directly. And once you go through my presentation, I think it will be more clear why it can serve to focus on these two goals. That is mainly the industry, innovation, infrastructure, and also responsible consumption and production. So this would be the brief outline of my presentation. So it would be introduction to additive manufacturing technologies. I would also be touching upon design for additive manufacturing and its role on material savings or sustainability. And also I would be talking about process selection for various component manufacturing, and also talking about the qualification aspects in metal additive manufacturing for space applications. And of course, I'll be covering various case studies from our own area in space applications. And I would also be talking upon future trends, opportunities, and again, concluding my talk finally with that. So when we talk about additive manufacturing, it is defined as the process of joining materials to make objects from 3D model data, usually layer upon layer, as opposed to subtractive manufacturing. So suppose if you take an example of a part that is shown something like this here. When we talk about subtractive manufacturing, we may have to take a block which encompasses this particular component shown here, and we need to remove a lot of material from that. And when we talk about additive manufacturing, you can in fact build this part layer upon layer without much of material wastage. So that is how additive manufacturing scores. And when you talk about the process flow, it is starts with the CAD software wherein we have the 3D model. From that, we have the .htl file, which can be the input to the CAM software, which in turn generates the toolpath or the command file for this 3D printer. And with the material as input to the 3D printer along with the toolpath or command file, we can print this part layer upon layer, and thereafter we have to subject it to various qualification and inspection activities before it can be inducted into the program. So again, you would have heard about many synonyms of additive manufacturing, such as rapid prototyping, 3D printing, or direct digital manufacturing, layered manufacturing, and also additive fabrication. All these are synonyms of this. And again, when we talk about additive manufacturing, we are moving from design for manufacturing to manufacturing for design. So when you talk about the various metal additive manufacturing process that are existing, you can see here it can be broadly classified into powder bed fusion, directed energy deposition, and solid state fusion techniques. Again, if you look at the feedstock can be in the form of powders, or it can be in the form of wires, or it can be in the form of foils or rods. And coming to very specifically to powder bed fusion, we can have laser powder bed fusion or electron beam powder bed fusion. So the only difference is the powder is the feedstock, whereas the heat source is either laser or electron beam. And coming to directed energy deposition, we can have powder fed technologies or wire fed technologies. And again, laser can be a heat source. Yeah, again, laser can be a heat source that is called as laser powder DED. And when you're having wire, it can be either an electron beam, or it can be a laser, or it can be an arc. In case of a welding, it can be an arc wire DED process. And coming to solid state fusion techniques, we have three advanced technologies, that is ultrasonic additive technology, additive friction stir deposition, and cold spray additive manufacturing. So these are three solid state fusion process, whereas there is no melting of the powders or particles or the material involved, which is the feedstock. So coming to the capabilities of additive manufacturing, you can see here there are different capabilities I have listed here. Normally, parts or structures that are impossible or difficult to manufacture conventionally through conventional manufacturing technologies can be manufactured through additive manufacturing. And very often, parts with very fine, intricate internal structures or complex shapes can be manufactured through additive manufacturing route. And also, a single additive manufactured part can replace an entire multi-part assembly. And you can also manufacture parts on demand without the need for an entire factory of setup. For example, in a casting or forging industry, you need an entire production line which needs to focus on that particular manufacturing of that part. Whereas in case of additive manufacturing, you don't need that entire factory setup. So when I talk about the process further, you will have an idea about this. And also it gives us the flexibility of production of novel materials with unique physical and mechanical properties. And we can also repair or add new functionality on top of existing parts. So this in fact talks about sustainability. Instead of throwing away the damaged parts or worn out parts, we can repair them, or we can add some new functionality onto existing parts by way of different additive manufacturing process. So that way we can save a lot of resources, especially when we are looking at replacing components made of titanium alloys or super alloys, which are very expensive. So coming to the motivation on additive manufacturing for space applications, you all may be knowing how costly it is to launch a satellite into space. So the cost of injecting a payload into space can vary anywhere between $5,000 to $20,000 per kilogram, depending on the orbit into which you need to place that satellite. And once we have optimized designs in terms of weight, we can achieve weight savings, we can achieve part count reduction, which can directly translate into these kinds of cost savings. So any kilogram of weight saved as a part of your redesign for different process, it can directly translate into this kind of cost savings when you're talking about space applications. So by additive manufacturing, we are effectively looking at processes which are cost effective, making our systems lighter, more reliable, and in a short turnaround time. And we are also looking at advanced alloys with both exotic physical and mechanical properties. We can also look at different combination of alloys. We have various requirements in our space systems, wherein we may require bimetallic joints, multi-material joints, or functionally graded materials. And also there's tremendous scope for R&D for academicians. And most importantly, sustainability, both in terms of materials and manufacturing, would be there when you are adopting additive manufacturing. In terms of materials, there's a lot of material savings because of you can say near net shaped processing by additive manufacturing. And in terms of manufacturing, you are saving a lot of machining time and you are saving a lot of resources. In terms of carbon footprint and all, you have a lot of improvement by going for additive manufacturing. So by both these means, we are getting the benefit of sustainability by going for additive manufacturing. And for metallurgists, there are various challenges like space applications calls for extreme temperatures, be it cryogenic or elevated temperature or ambient temperature. The environments are often oxidation prone, corrosion prone, or embrittlement prone. And we are talking about very high pressure, static and dynamic loads, and also minimal design margins because we cannot carry too much of dead weight when we are talking about space systems. So we are working with minimal design margins. So when you talk about a major process in the iterative cycle of additive manufacturing of components, it starts right from the design or pre-processing phase, wherein we have to redesign the parts suitable for additive manufacturing, and we can have this part that needs to be printed in which orientation or what are the supports that are required, and you need to generate the tool paths in some cases where when you are adopting directed energy deposition techniques. And the actual process itself, you need to optimize the process parameters and material as the feedstock in the form of either in the form of wire or powder. And after the part is manufactured, it needs to be subjected to certain post-processing operations such as powder removal, heat treatment, support removal, build plate removal, final machining, welding or polishing and cleaning. And also whenever you are using the part in service, I'm getting a lot of disturbance actually. Yeah, whenever you are looking at part in service, it can be qualified or it can be monitored during assembly. It can be monitored while the part is in service. And also we need to qualify and induct the part as a part of the production plan. So at all these stages, there are various qualification aspects involved. So I'll be talking about those things also in detail further. So when you look at metal additive manufacturing for space applications world scenario, ISRO was the early adapters of this technology. Of course, it was not a launch vehicle component, but it was a satellite component as shown here. The Northwest Field Cluster, which had flown in GSAT 17 flight, GSAT 19 flight, and also SpaceX has been extensively using additive manufacturing for development or manufacture of their Super Draco engine, the Merlin engine main oxidizer valve. And ESA has also adopted additive manufacturing for Ariane 6, especially the propulsion module shown here. You can see here more than 240 injector elements are there, which used to be earlier machined separately and brazed onto this particular injector plate. Now they are 3D printing this entire component as a single component. And you would have seen very large components such as propellant tanks being made by Relativity Space as shown here. And also our own startups have 3D printed their cryogenic and semi-cryogenic engines. You've also seen some electrical engines by Rutherford from Rocket Lab. They have been 3D printed. And one very important application is the aerospike nozzle. In fact, it is very difficult to imagine such component to be made through conventional manufacturing technologies. So that has been 3D printed, and also as shown here, you have a lattice structure for achieving very good cooling during the combustions. So that has Cellcore has adopted additive manufacturing for 3D printing of this engine chamber. So these are different. This is not all. It is only a glimpse of different applications. So maybe when you Google, you will find more and more applications for space. And yeah, again, I talked about the propellant tanks by Relativity Space. And also you can see here how additive manufacturing has simplified the engine right from Raptor 1 to Raptor 2 to Raptor 3. When they have totally gone for 3D printing, they have done a lot of part count consolidation, and they have simplified the rather complex engine that used to be made through conventional manufacturing route earlier. And also one such component that has been extensively used by GE is the engine fuel injector in all the commercial aircrafts that are being flown daily from various places. And also you have seen a lot of aircraft brackets, engine parts, and also the nozzle divergents have been 3D printed extensively by different space agencies. So one such potential of additive manufacturing by way of design is going for a design for additive manufacturing. And also you can achieve part count reduction as shown here. This is a fuel injection nozzle wherein more than 20 components have been made as a single component by adopting additive manufacturing, and wherein they could get 30% weight savings and also better performance. And on the right, you can see we have adopted the design for additive manufacturing approach. And this is a conventional manufactured component. The component weighs around 21 kilograms. And we have done a design for additive manufacturing of this component and redesigned this component, which weighs only now 15 kilograms. So almost 30% weight savings we could achieve by adopting a design for additive manufacturing approach. So many of you may be wondering what is design for additive manufacturing. So this particular slide gives an example of design for additive manufacturing. So on the leftmost on the top, you can see this is the old design. So here you can see there are some areas which may not be really required from functional point of view, but only from manufacturing point of view, it would have made in that way. So we are trying to remove the material wherever it is not really essential. And since I talked about additive manufacturing, we have flexibility. There is no constraints. We can redesign the component. So we are doing effectively a topology optimization and redesigning the component. And of course, when the component is being redesigned, we need to analyze whether it can take those kinds of loads which it is meant to serve the purpose. So we need to carry out an analysis again, and once we see that yes, your new design can meet the required functional requirements, you can go for manufacturing by, of course, by 3D printing. So this particular bracket shown here is an example of ESA satellite Sentinel-1 bracket, wherein a weight savings of almost 40% could be achieved. So from 1.6 kilograms to 936 grams, they could bring down this bracket weight. So many of you may be wondering, okay, this mass saving is very, very limited. So just imagine you can load 700 grams of additional propellant when you are saving this kind of mass, and that 700 grams of propellant can extend that satellite life by at least 2 to 3 months. So this is one such example of a component that is there in the satellite. So when you are redesigning many such satellite components, you can imagine like what is the kind of weight savings you get. Suppose you save 2 to 300 kilograms. So you can load that much amount of additional propellant, and it can in fact extend your satellite life by 2 to 3 years. So coming to the various design aspects, so you can see here when we talk about design aspects, the first one which comes to our mind is design for additive manufacturing, where we are trying to optimize the geometry, we are trying to have a part count consolidation, and also we can adopt lattice structures, or we can do a topology optimization to achieve those weight savings. And also it is important to have proper process selection. So depending on the process capabilities, we need to choose the process, and sometimes we may have to choose a combination of different additive manufacturing process to make a particular component. And also you need to look at what is the part size and feature resolution to choose a particular process. And also we are looking at complex geometries in many cases. We need to also look at post-processing requirement, machining, surface finish, all those requirements we need to look at. And another important aspect is the thermal management, which is very important because the process parameters that we choose are really important in seeing how the residual stresses are built up in the component that is being manufactured. And it is also important to adopt proper scan strategies and minimize the support structures so as to minimize the residual stresses. So all these form a part of your design or the pre-processing part of your additive manufacturing. And also it is important to have proper material selection by way of alloy design, heat treatment, or combination of heat treatment and hot isostatic pressing and heat treatment to give the necessary advantage of mechanical properties. So coming to the different process for metal additive manufacturing, so I talked about powder bed fusion process, wherein you can have either electron beam or laser as the heat source. And also when we talk about directed energy deposition techniques, you can have powder and wire as feedstock, and you can have either laser or electron beam or plasma as the heat source. And another important technology that is solid state additive manufacturing technology that has been gaining more popularity is cold spraying technology. I'll touch upon one or two case studies on that as well in my future slides. So coming to the primary metal additive manufacturing process for space applications, so based on the fusion technique or based on the feedstock, I've listed down the process or classified the process. And both the powder bed fusion process can be classified as small format process, mainly because of the size of the components that can be made through these two techniques. Whereas when you talk about large format or large size components, you have mainly directed energy deposition and solid state additive manufacturing technologies that are shown here. And when you look at process selection for aerospace, of course, all these attributes are very important. Uh, but the main things that you need to keep in mind are what is the overall part size, what is the feature resolution, or what is the minimum feature size in that particular component that needs to be made, and also the industrial maturity of that particular technology. So when we look at all these aspects, you can choose any particular process for aerospace applications, provided it meets the technology readiness level of 6 and above. By that, what I mean is any part that has been made through this additive manufacturing process should have been qualified at lab scale in that particular environmental conditions. So if your part that has been made through any process has satisfactorily performed in those environmental conditions in lab scale, so you can say your part has met TRL level 6, and you can adopt that process to make the components for space applications. So on the right here, you can see various processes based on the size capabilities. So when you talk about laser powder bed fusion process, so components as large as 1 meter by 1 meter can be made, and in fact, this particular domain has been increasing. Now we have few commercial printers in the world which can print components as large as 2 meter by 2 meter or 2 meter by 3 meter kind of sizes. And when you're looking at very large size components of 4 meter or 5 meters, you can see arc wire DED process is the technology, and all of the process fall in between these two extremes. So again, why you need to look at different metal additive manufacturing process? So when you're looking at a very high complexity in your component, very high dimensional accuracy, very good surface finish, laser powder bed fusion is a technology. Similarly, when you're looking at very large build rates or maximum volume of a component that can be printed, and also very minimal material wastage or very high material utilization and overall cost savings, wire arc additive manufacturing is the technology. And other technologies such as electron beam powder bed fusion is at least one order lower than your laser powder bed fusion, whereas laser metal deposition, which is nothing but powder DED or wire DED processes, they fall between laser powder bed fusion on one end and wire arc additive manufacturing on the other end. So we need to keep in mind different, the different capabilities of these processes as shown here, so as to choose a particular process for making your component. So again, this slide explains the same thing in a slightly different manner. So when we plot the resolution versus the part size, so you can see here powder bed fusion technologies. You can make components with very high resolution or of complex geometries. But again, the part size that can be made through this process is limited. And again, when you're trying to make very large size component with low feature resolution or simpler geometries, you can adopt a powder DED process or a wire DED process. And again, the color indicated inside these ellipses give an indication of the cost of these processes. So the powder bed fusion is quite expensive compared to wire DED process. And when you look at machines that are available in the country, there are a lot of laser powder bed fusion machines available, whereas very few lab scale machines are available in DED process, but not many machines of large size or commercially available machines are not there in the country, which can make very large size components. So again, here you can see the feature resolution versus the deposition rates. So you can see here as your deposition rates are increasing or the material deposition rate is increasing, you need to compromise on your feature resolution. So in case of laser powder bed fusion, you are able to get very high feature resolution, but you need to at the same time compromise on the deposition rates, because you can see the deposition rates are quite low. Whereas in case of additive friction stir deposition, which use powders, the feature resolution is not as good as laser powder bed fusion, but you can definitely get very high deposition rates. And when you talk about AM build cost versus the part build volume, you can see here as the size of your component increases, of course, you need more material, so the cost increases. Whereas when you talk about AM build cost versus the deposition rates, so you can see here as your deposition rates is increasing from left to right, your AM cost decreases. But again, most of these technologies with very high deposition rates are near net shape technologies. So there you need to do some amount of machining, post-processing in the form of machining, which can again add to cost. So it is effectively a trade-off between your deposition rate versus your post-processing requirements. So you need to be careful in selecting a particular process. So again, this again represents pictorially the build deposition rate and your feature resolution. So when you're talking about very fine resolutions, you are looking at powder bed fusion process, wherein you can get very high feature resolution in your components that need to be made. And when you're compromising on the feature resolution and you can go for very high build deposition rates, you are looking at all these processes. And one common feature about this is as your feature resolution is increasing, that feedstock size decreases, with an exception of cold spray process, wherein again the powder size is almost similar to that of laser powder bed fusion, that is on this extreme. In case of cold spray also, we use 10 to 45 micron powder, but your deposition rate is quite high because there is no melting of these powder particles that is involved. Whereas almost all other processes, there's melting of the powders or wires that are involved. And in case of laser powder bed fusion, again, you have 10 to 45 microns. In case of EV powder bed fusion, you have 45 to 105 microns. And in case of DD process, you can have powders or wires which are larger in size. And wire diameters can typically go up to 3.2 millimeters in diameter when you talk about arc wire DD or electron beam directed energy deposition process. So again, when you compare the as-built surface condition of various processes, you can make out from here the part that is shown in process B is from laser powder bed fusion process, whereas the first one is arc wire DED process. So you can see here the surface is quite rough. And the third one is laser wire DED process, and the fourth one is laser powder DED process. So you can compare in between these two because of this feedstock size change. You can see the kind of waviness or the surface finish that is changing from powder DED process to wire DED process. Yeah. So we now move on to quality control aspects in metal additive manufacturing for space applications. So the main important thing why we are looking at quality control is reliability of parts is most important, especially when you talk about space applications or any complex applications. And it is also important to note that this particular manufacturing technology is relatively newer compared to other conventional manufacturing technologies. So there are very few standards that are available for qualification, certification, and also there's complex combinations of machines, materials, and process. And also there is absence of reliable AM databases, which reduces the level of confidence to adopt this AM process into the supply chain. And most importantly, we need to look at what are the build process parameters that are used to qualify the process. And also we need to look at qualification of parts rather than a family of parts rather than individual components. Because when you go into mass production, this plays a key role. And it is also important to have proper non-destructive technologies for qualification of your AM parts. So when you look at the various standards, there are different standards from ASTM and AMS for powders and for mechanical properties and for heat treatment cycles. Of course, this is for conventional alloys. And for most of these additive manufactured alloys, we have the original equipment manufacturer data sheets, which can be used as reference. And you can see here, there's one comprehensive standard from American Welding Society, that is AWS D20.1 for AM components, as well as both for AM components and non-destructive testing of AM components. So based on all these available standards, we have been devising our own standards, and we have been generating a lot of data by carrying out a lot of testing and also looking at various NDT capabilities of different non-destructive testing technologies. So this table just gives a glimpse of what are the different alloys and different heat treatment, what are the kinds of mechanical properties that are achievable specified in different ASTM standards. So this is just a glimpse to give a glimpse of different alloys like AL acetate aluminum alloy, Inconel 718, a nickel-based superalloy, Inconel 625, again a nickel-based superalloy, stainless steel 316L, titanium alloy TI6L4V and TI6L4V Li. So like that, there are different ASTM standards for different materials, and they specify properties in different orientations and also in different heat treatment conditions as shown here. So I'll talk about the qualification methodologies that we are adopting for additive manufactured components. So we are looking at 5-stage qualification, I would say. So the first stage starts with powder or raw material stage qualification. So when we are using the powders for making these components, we need to ensure that the chemical composition is as per the alloy specification. The shape and size needs to be determined. We need to have spherical powders to ensure very good flowability, and also we do carry out flowability tests. We check the apparent density, tap density, and the ratio of tap density to apparent density is again called as Hausner ratio. So we need to ensure all these parameters meet our specification requirements. Only then we can say that the powders that we are going to use are qualified enough to print the component. So the next step is very important. It's called as equipment qualification, wherein we need to qualify the machine, the heat treatment furnace, and also the machines that are used for carrying out the machining and the measurement, and also the vibration sieves for the powders. After all this, we move on to the most important or the crux of additive manufacturing, that is the first article inspection stage. Here we are trying to qualify the machine for 3D printing that you are going to use for 3D printing, the material that you are going to use for printing, and also the process parameters. So all these three elements we are going to qualify as a part of this first article inspection stage. So here what we do is we carry out an exclusive build of coupons, test coupons in the form of cubes, test coupons for making tensile specimens, and we evaluate density, microstructure, hardness, physical properties, and also carry out non-destructive testing of test coupons. We evaluate mechanical properties on the tensile coupons that we have printed, and also sometimes we carry out cut-up tests as in case of castings. Similar to that, in case of castings, we carry out cut-up tests. And also we can subject the part that has been 3D printed for the first time, we can subject it to functional testing. So only after all these requirements are met, we move on to the production hardware stage. So here, along with the component, we do print some samples for carrying out mechanical property evaluation. We do carry out non-destructive testing of all the coupons and components. And of course, since we have moved into a production phase, we carry out functional testing on random hardware just to ensure the production process is in control. And after all this, we need to look at post-processing. It can be in the form of heat treatment. It can be a stress-relieving heat treatment. It can be a solution treatment and aging. And also it can be machining, surface treatment, or short blasting to achieve the required surface finish as specified in your drawings. So only once we have completed all this, we can induct a particular component into our space application. So this slide gives a glimpse how different coupons are printed in different orientations. So you can see here coupons are printed in Z direction, in X direction, and in 45 degrees. So this particular build is called exclusive build of coupons. Again, you can see there are different types of specimens that we have printed for checking the density, the microstructure, the mechanical properties. And here in the second image, you can see these are 3 different components. Along with that, we print the components in Z direction and in X direction. And after this component is parted from the build plate, we have to subject it to computed tomography inspection to see whether all the internal features are formed properly and there are no blockages with powders. We evaluate the microstructures in 3 different orientations. And once the part has been made and heat treated and machined, we subject it to structural testing. And when we talk about structural testing, we often subject the components to 4 times the expected loads that we encounter in service before inducting a component into our space program. And we can also use computer tomography for carrying out dimensional inspection. And very often we try to rely on in situ process monitoring techniques for process control. Instead of testing each and every component after printing, we can also look at in situ process monitoring to ensure your process is in control. So we can have various sensor based monitoring techniques, imaging and vision based systems. And we generate a lot of real-time imaging and analysis of printing process to detect the defects, anomalies, and we can assess the layer by layer quality during the process of printing itself. So that's why we call it as in situ monitoring. And like this, when we acquire large data for different builds that we carry out, we need to look at those data and we need to analyze those data and we need to identify some trends and correlations and which can be very good predictive indicators of the part quality. And of course, most important or the crux of this in situ monitoring technology is the robust sensors for both real-time and accurate, reliable data acquisition. And also we are looking at integrated monitoring systems. So the advantages of all this is we can detect your defects early, we can minimize the scrap and rework, and also we can look at optimizing the process parameters to improve reliability. And all this gives us enhanced confidence in the quality and consistency of AM components. So one such in situ process monitoring technique is online melt pool monitoring technique, mainly for defect detection. So here what we try to do is using this software, we try to get a thermal energy density map for that particular layer of part that is being printed. And you can see here, any local variation in the thermal energy densities can give an indication that there may be some defect concentrated in this location. So you can see here, while this part is built from bottom to the top, each particular layer of this particular part we are monitoring using this technique, and we get one such image for each of those layers from bottom to top. And you can see at this particular layer, you can see a lot of defects are there. So here you can take a call whether these kinds of defects are acceptable for the final component, or if it is not acceptable, you can stop the process and you can avoid the wastage of your machine as well as the material by discontinuing at this place. Suppose you see that okay, this kind of defect are okay, and my part it should not create any problem, you can continue with this particular process. So we do carry out a lot of simulation. Simulations can result in improved efficiency by way of optimized process parameters. We can also mitigate the risks. We can mitigate some build failures, and we can minimize the residual stresses. So simulation helps us in saving a lot of time and resources. You can during the simulation itself, you can encounter. What are the kinds of residual stresses or build failures that can be encountered can be simulated, and you can again redesign your component, or you can add more supports to avoid such scenario. And also we are looking at improving the surface finish distortion control by carrying out simulations. So by all this process, we are looking at cost reduction either by way of support structure optimization, and very often we try to print part right in the first time itself, so that we avoid rejections and we save a lot of resources. So coming to metal additive manufacturing in VSSC, this slide just gives a glimpse of different components. Of course, this is not all that we have done. This is just a glimpse of different components that we have done in various alloys like 316L, titanium alloy TI6L for VLI, aluminum alloy ALS at NMG, Inconel 718, and again aluminum magnesium scandium alloy. Different components we have printed using laser powder bed fusion, and we have carried out qualification of almost all these components before inducting them into our program. Yeah. So the first case study shown here, there are two types of stainless steel brackets that we have printed in SS316L. The specification of this SS316L for wrought alloy is shown here. It is 205 MPa minimum yield and 515 MPa UTS, 30% elongation and 40% RA. This is the spec for wrought alloy. And of course, when we make this components through wrought alloy, we could get these kinds of properties. And when we 3D printed the same components, we could get, you can see here, very high yield strength, and of course, slightly higher UTS compared to the specified values. So that has given us advantage. We can definitely go for redesigning the component because we are able to get almost double the specified yield strength in case of 3D printed components. So these components, we have carried out extensive characterization and NDT, and we have structurally tested them to 4 times the expected loads. And we have done detailed qualification as per the standard that I mentioned, AWSD 20.1. Of course, we have carried out all those 5-stage qualification along with exclusive build of components. And these are the first components to fly in our ISRO launch vehicle as structural elements in both SSLV D1 and D2 flights. And you can see here, these have been integrated with the ring after carrying out structural testing. And just to give a glimpse of why additive manufacturing is advantageous, to realize this bracket, you need to take a block which weighs almost 100 kilograms. And you are machining out almost 96 kilograms of material to realize this particular component. And when we adopt the same thing through additive manufacturing, you can see here the material wastage has been minimized to less than 5 kilograms. And when you redesign this component, you can still bring down the weight to almost 1.8 kilograms. So you are hardly wasting 2 kilograms of material. And you can see here the most important advantage we get is cycle time reduction from almost 55 days. We are able to bring down the cycle time to 5 days. And of course, during initial development phase, the cost may be higher, but maybe when we adopt a design for additive manufacturing approach and redesign the component, we can make the cost comparable. So here you can see these are different components as shown here that we have printed in titanium alloy. Here again, we are able to get 20% cost advantage than the conventional route. And we have carried out extensive testing in 4 different orientations, X, Y, Z, and 45 degrees. And against the specified values, you can see here in almost all the directions, we are getting very high mechanical properties. So that again gives us the flexibility to redesign the component and save further weight. And we have evaluated the impact strength also because these components require some impact strength to be determined. So another important component is fuel injection strut in Inconel 718, which has very fine interconnected complex fuel channels with very small injector holes. And you can see here this CT image, and all these channels are interconnected with each other. And you can see here these are opening to around 0.8 mm diameter, and here the diameter is around 3 mm. So it is difficult to make this particular component through conventional manufacturing technologies. So we have adopted 3D printing, and you can see here we have again carried out extensive qualification of this component before inducting into our program. We have evaluated the properties in different orientations, and you can see here the properties are again well above the minimum specified values. And we have done extensive computer tomography to see that there's no blockage of all these channels because this particular component is used as a fuel injection component. Yeah, this is another example of aluminum alloy component made in aluminum 4.8 magnesium 0.3 scandium. And earlier this particular component used to be made from a forging of 2014 alloy. So these are the specified properties for that alloy. And when we adopted this particular alloy and we did the 3D printing of this component, you can see here we could get properties well above the specified properties, and without any compromise or matching elongation against 5%, we could get around 13 to 15 or 19% elongation. Here again, we have done detailed qualification of this component before inducting into our program. So another example is manufacture of a large size titanium alloy dome. This is through conventional manufacturing. We used to take a billet weighing around 60 kilograms and used to carry out closed die forging. And the final component weighs only 12 kilograms. So the material wastage is 48 kilograms. And the operations are also reduced when you try to make it through 3D printing. And the cycle time also more than 75 days, we could bring down to less than 5 days. And you can see it gives us a cost savings of almost 25%. And material wastage is minimized to less than 6 kilograms. We are trying to print near net shape components, so we need to definitely do some machining. So there will be some material loss. So the as printed component weighs around 18 kilograms and the final component weighs only 12 kilograms. So only 6 kilogram material is wasted as compared to 48 kilograms in case of conventional manufacturing. So that's where we get a lot of advantage or benefit in terms of sustainability of natural resources because these are expensive materials. So another example is a large size grid fin component. So to make this particular component, which weighs only 120 kilograms, it used to be machined out of a forging weighing more than 2.5 metric tons. So you can see here the buy to fly ratio in case of a conventional manufacturing route is around 21. Whereas in case of additive manufacturing, we could bring down the buy to fly ratio to less than 3. And you can see here both these brackets also are 3D printed to make them integral. So almost 5 different components we have 3D printed as a single component. Of course, when you make it to conventional manufacturing route, all these brackets need to be fastened onto this. So there are a lot of fasteners involved. All those part count we could reduce to a single component. And here again, we could get a cost saving of 25%. So this particular component also has been extensively characterized and it has been tested. And I can tell you, like, this is the largest retailly manufactured titanium alloy component in the world for aerospace applications. Of course, this was printed at Shiaki, USA by electron beam additive manufacturing process. And we have carried out detailed mechanical property evaluation in 4 different orientations, and this is the specified properties. You can see here we are getting these values specified here, and all these directions we are able to meet the minimum specified properties. And again, 70 MPa root meter fracture toughness values, you could get all the values more than 100 MPa root meter. And to realize this particular component, we have used TI7AL4V because in this process, being a high vacuum process, there's bound to be some aluminum losses. So the final composition of the alloy needs to be within this spec. So we have chosen higher than that particular alloy spec aluminum content. So after printing, you can see even after aluminum losses, we could achieve the final chemical composition specified for this alloy. And we have done microstructure analysis, tensile testing, and fracture toughness, as I mentioned already. And this particular component also has been qualified. We are also looking at very large size 3D printing technologies for making such components of around 2.4 meter diameter and 3 meter diameter. So these two components we can make through wire arc additive manufacturing technology. Similarly, we are looking at making very large size components as shown here. It's a copper nozzle. So you can adopt cold spray additive manufacturing technology. As I mentioned, there is no melting of powders involved. You can you don't need to have ability to join parts with I mean, you don't require weldability of these powders. Powder is only required as a material to be deposited, and you can make near net shaped components with buy to fly ratio as close to 1. And also it's a very fast and green process when you talk about sustainability. And alloys that are not amenable for welding also can be chosen. You only need to have the feedstock in the form of powders available to make those particular components. So similarly, you can make these components as shown here. You can have these kinds of grid plates made through cold spray additive manufacturing process. So other typical case studies, one such longeron component which has an envelope of more than 1 meter by 1 meter. This can again be made through cold spray process. Of course, you need to machine out these pockets after deposition of that bulk process. So similar.
Sir, Anil sir, you are unmuted. You are muted, sir. Please unmute, sir.
Yeah, whether somebody has muted me. Am I audible now?
Sir, your voice is audible now.
Okay,
Yes, sir.
okay, yeah. No, whether somebody has muted me because I have not done anything.
Yes, sir. I had done, sir, because one participant is
Okay,
unmuted, so
okay,
that's
fine.
why I muted.
Yeah,
Okay, sir.
okay,
And
no
carry
issue,
on,
no
sir.
issue. Yeah, okay. Yeah, so we have done a redesign of this component, and you can see here, once we adopted DFAM, the weight has come down from 3.6 kilogram to 2.5 kilograms, and this can directly relate give us a cost savings of around 80 lakhs per flight. And coming to long-term vision of VSSC in metal additive manufacturing, so we started with development of passive launch vehicle components in 2021, and we have done a lot of characterization on various 3D printed components, and we are trying to understand the process design. We are doing a lot of simulation, and we are getting hands-on experience on various processes like GED, electron beam, and wire arc additive manufacturing process. And based on all this understanding, we are looking at developing active launch vehicle components such as engine parts, and we are also looking at consolidating multi-parts as shown in the grid fin. And based on all this understanding going further, we'll be looking at designs, functionally graded materials, and also looking at new and futuristic alloys for space applications. And going further, we will also be looking at 3D printing of complex systems for our space applications. And as a part of all this, our main focus has been on design, on the materials and the processes, and also the post-processing and the qualification of the components. So we at VSSC are establishing a center of excellence in additive manufacturing. So we do have the DFAM and simulation software for the AM process that have been commissioned. And we also have one laser powder DED process and also a laser powder bed fusion process running at our place already. And currently, one electron beam additive manufacturing machine is also being commissioned, and shortly we'll be releasing the order for wire arc additive manufacturing machine and one inert gas atomizer for making the powders. So, if you look at our way of establishing the center of excellence, we started with product development before establishing the facilities at our place. So, we looked at various processes and looked at suitability for their applications for space. And based on that, and also based on our understanding of various processes, now we are establishing the process, and we have been carrying out fundamental R&D and process development. And going further, we would be able to be in a position to transfer this technology and carry out large scale production through Indian industry. So when you talk about directed energy deposition process, so we are using laser as the heat source, and we are feeding powder through these channels, and the laser can melt and deposit onto the substrate, and this particular process can get repeated layer upon layer to build the full component. And one such machine is there with us, which is capable of making 1.8 meter by 1.2 meter by 1 meter in 3-axis mode, and in 5-axis mode it can make dia 800 into 800 mm. And typical components through this process include impellers, exhaust casings, functionally graded materials, and also multi-material components. So when you look at the applications of DED, we are looking at repair or cladding operations. We are looking at feature addition onto existing parts, and also we can make near net shape parts. So when you're talking about sustainability, we are looking at refurbishing of the worn out parts, or maybe if your part has not been designed properly and you want to add some stiffeners onto it. You can add some features onto it. Instead of throwing away that previously manufactured part, you can adopt a DED process to achieve this kind of sustainability as shown here. So you can fabricate parts, you can repair the parts, and also you can print multi-material and bimetallic components through directed energy deposition. And also, I talked about electron beam additive manufacturing. So this particular process is mainly suitable for reactive and refractory alloys, as this particular process happens entirely in vacuum. It's a fast process for making very large size parts. Of course, we use wire as a feedstock, and all weldable materials can be 3D printed using this technique. And of course, we can print large size components in a reduced lead time. We can print titanium alloy propellant tanks, thrust chambers in copper alloys, gas bottles again in titanium alloys, and grid fin components. So typical materials that can be 3D printed include titanium and niobium alloys. So again, we are also looking at a very large size wire arc additive manufacturing machine, which can print components up to 5-meter class, mainly interstages, rings, propellant tanks, large size brackets, and typically weldable materials like aluminum alloys, titanium alloys, and also stainless steels. So this process, again, it combines automated metal inert gas welding, and it can also use laser hot wire welding to improve the surface finish. You can make very large size components. And we are looking at a central robotic welding arm with wire feeder. And this robotic arm can be mounted on a gantry to achieve very large size component builds. And most importantly, all weldable materials can be done. And again, if you want to print titanium using this technology, you need to have controlled atmosphere locally, which uses argon gas for shielding that particular deposits. So when you look at success story of VAM technology, Relativity Space has some of the world's largest 3D printers, and they have been able to build and fly rockets in a matter of days. So Terran 1 is one such example, which was the world's first 3D printed rocket, and it has been flown successfully. And based on that, they are developing a larger size rocket called as Terran R. Again, the part count reduction, when you talk about launch vehicle, the part count can run into lakhs, whereas by adopting additive manufacturing, they have brought down the part count to less than 1,000 and a build time of 2 months, and also simplified their supply chain. So that is the advantage of additive manufacturing. So coming to the opportunities in metal additive manufacturing for space applications, you can see here there's tremendous scope for R&D by way of collaborative projects with academia in the area of modeling, simulation, design for additive manufacturing, topology optimization, anisotropy in mechanical properties, texture, residual stresses, microstructure, and also surface finish. We are also looking at online process monitoring software as used as quality control tools. And also we have a lot of requirements of various powders and wires as feedstock material for different additive manufacturing techniques that I talked about. We are also looking at online inspection and NDT tools to minimize the inspection time and cost after the component is made. So in situ monitoring and inspection technologies are the ones we are looking. And we'll also be looking at AI and ML based processing, inspection, quality control software. And also there'll be a lot of opportunities for startups, hubs, and center of excellence in aerospace parks, which are looking at making components through additive manufacturing. And of course, as the technology grows more and more in the country, there'll be a lot of requirement for training centers. So when you look at the different components that we have made through different additive manufacturing routes, you can see here this is a very large size grid fin component. So you can see here as a human is standing, you can make out the size of the component. And similarly, domes for gas bottle applications have been made through wire fed electron beam process. And using laser powder bed fusion, we have made various components as shown here: struts, gas bottles, nozzles, and also lattice structures, sandwich panels, filters, nozzles in copper alloys have been made. And we have also adopted DFAM for redesigning some bracket component and saving a lot of weight. So coming to the opportunities for Indian industry, we have looked at various technologies and also various components. So we have a lot of requirements for various sizes of gas bottles like dia 600, dia 400 titanium alloy gas bottles, which can be made through electron beam or wire arc additive manufacturing route. As shown here, we can make two such domes and carry out machining and EB welding of those domes to realize the gas bottle or the propellant tank shown here. Similarly, we have lot of requirements of 1.2 meter class domes for our PSLV, PS4 propellant tanks. So here again, you can make them through wire-fed electron beam additive manufacturing route and carry out machining and welding to realize the entire propellant tank as shown here. Again, we have made this particular grid fin component through electron beam additive manufacturing. Similarly, you can make copper nozzles through either cold spray additive manufacturing or directed energy deposition routes as shown here. And also large size titanium alloy components, Inconel 718 components can be made through directed energy deposition route by doing the deposition and machining. Similarly, here you can see we have identified some bimetallic components through directed energy deposition process, such as titanium stainless steel Inconel combination, Inconel and copper and stainless steel. Again, so these are few examples shown here. This is one such nozzle from Korean Aerospace Research Institute with both Inconel 625 and aluminum bronze using directed energy deposition. Similarly, functionally graded materials can be used for making these nozzles for reusable launch vehicles. Again, you can use directed energy deposition because you need to tailor the composition from one end of this component to the other end. Of course, you can adopt a powder DED process to do this. And we have a lot of requirements for honeycomb panels as shown here, both in aluminum alloy as well as in titanium aluminides for both structures as well as high temperature thermal protection systems. We have such requirements for lightweighting applications. Similarly, we have requirements of oxygen storage gas bottles in Inconel 718 for our human space program or for the Gaganyaan program. We have such gas bottles which can be 3D printed and machined to be used for that. Again, I have shown examples of large size aluminum components that can be made through any of these routes shown here, either cold spray additive manufacturing or additive friction stir deposition or wire arc additive manufacturing routes. So coming to the key learnings, what we have seen during our journey is the process parameters that you use for printing of components and the feedstock both need to be of good quality. Otherwise, if either of your process parameters are bad or your feedstock is bad, you will end up with making a bad component. And also, it is very important to clearly define the specifications without any ambiguity in the development stage so that you don't end up with losing out in the development cycle. And also, we are looking at building a partnership rather than a vendor-customer relationship with all our vendors. So we try to jointly develop components when we are trying to make through Indian industry. And also, we have been using standards as guidelines, and we have been devising the acceptance criteria based on the end use. So depending on a particular end use, maybe we need to carry out impact testing or fracture toughness or even high temperature tensile tests. So based on the end use, we determine what are the tests required. And during the development phase, every data point needs to be carefully analyzed. Whether it is good or bad, you have to analyze why it is good or why it has gone wrong. Needs to be analyzed carefully. And also we need to optimize the process parameters and post-processing parameters such as heat treatment or hot isostatic pressing for different components to optimize the mechanical properties and tailor the mechanical properties. And most important learning has been there's no alternate to functional testing to gain confidence before inducting the process into our supply chain, product into our supply chain. So one such example shown here is functional testing of various thrust chambers by NASA. They do extensive hot fire tests. More than 11,000 seconds of hot fire tests have been done, and more than 250 plus tests have been done before these kinds of components are inducted into their program. And during one such functional test, you can see here this particular nozzle has got damaged. It has sheared and it has flown away, and When they tried to see what has gone wrong during 3D printing of this component, they noted that it was because of build interruption uh, that has led to this problem. It was not actually the build interruption, but somebody had opened the chamber before that build process has been completed. So that led to contamination locally, and that particular defect could not be detected. And based on this learning, they have suggested full height specimens to be built along with all components to characterize the material. And if you see here, this particular learning has been published by NASA in 2022. Even we had one such recommendation, and we have published one work in 2021, wherein we also recommended full height specimen to be built with all the components. So here you can see when we first developed the two stainless steel brackets that I had shown for VTM brackets. Uh, in the first batch that we made, you can see here the samples in 45 degrees failed prematurely with very low elongation, although the strength was meeting the requirement. And this particular root cause was attributed to incomplete melting of powder due to a build plate setting error, although the root cause was different. Our recommendation in this particular case also was to print Z direction specimens to full height, full build height. So in fact, we have been following such criteria in all our builds. And coming to the future trends in design, simulation, and qualification EM in additive manufacturing, we going further in future, we'll be looking at in situ manufacturing, wherein we'll be looking at manufacturing of space, I mean spare parts, and also infrastructure on site, both on Moon and Mars. And going further, we'll be looking at a lot of digital twins and simulation for carrying out virtual testing, optimization, and process performance predictions. And as a part of our journey, we'll be looking at standardization and certification for generating industry-wide standards for various processes and materials. Of course, sustainability and recycling is one very important thing. We'll be looking at more and more eco-friendly AM process and materials. And also we'll be looking at in situ material characterization to assess the properties in a real time. And we need to carry out a lot of multi-physics and multi-scale modeling and simulation to predict the mechanical properties. And also we need to predict the microstructure. We can predict the grain growth, phase transformation, and also predict the defects by using different softwares during the printing process itself. You can also use process parameter optimization by way of AI and ML based algorithms, and real-time correction can be done during the process is happening. And you can also carry out virtual qualification and certification through simulation based approaches rather than testing of each and every component that is being made. And also we'll be looking at open source simulation tools for both entire additive manufacturing process cycle. And also we'll be looking at advanced NDT for AM components, because most of the conventional non-destructive testing technologies are focusing on regular shape components. So when you talk about additive manufacturing, we are looking at near net shape components. So we need to look at advanced NDT techniques which can detect the defects in near net shape components in a reliable manner. So to conclude, I can say additive manufacturing is a disruptive technology that has been growing exponentially worldwide and gaining more popularity in space sector. And there has been tremendous potential for replacement of numerous conventional parts and assemblies by AM parts using DFAM in space sector, design for additive manufacturing. I talked about this aspect wherein we are able to save a lot of weight, so that gives us sustainability as well as innovation. And we are looking at development of critical and complex component systems and assemblies of various sizes through different AM routes that have been qualified and inducted into space programs already by different space agencies. Of course, there are a lot of certification challenges that remain to be addressed so as to accelerate and induct AM components into supply chain in space sector especially. And coming to one of the future trends, we'll be looking at reliable and online AI and ML based techniques, mainly for process monitoring, inspection, and quality control of the components. I think, yeah, with this, I would like to conclude my talk, and I would like to acknowledge my management and also organizers of this FDP at Vikas Engineering College. and also my colleagues at MME VSSC and all my partners, collaborators in VSSC in metal additive manufacturing, and also the audience for a patient hearing. Yeah. So thank you once again. So I would be open to questions if any.
Thank you, sir, for that insightful and well-structured presentation. The concept you have shared today has given us a deeper understanding of the topic, sir. Thank you so much. I would like to ask the participants if there are any questions or clarifications regarding the presentation, you can ask to the sir. The faculty members, if you have any questions to ask, you can ask to the sir. There is no questions? Thank you, sir. Now I'm going to handle the program to Ashwin, sir.
Thank you, Sukirti. Thank you, Anil sir, for your valuable time and for your great presentation, sir.
Thank you.
Thank you, sir. Sir, Vikrant sir, are you there, sir? Vikrant sir. Hello, Vikrant sir. Vikrant Vijay sir. Are you there, sir? Vikrant Vijay sir. Sir Pawan sir. Participants, we'll wait for the next speaker. Dear participants, next speaker is Mr. Vikrant Vijay Shitole. He will join the meeting. It will start by 8 p.m. Please wait, dear participants.
Hello, good afternoon, sir. Hello. 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 Hello.
I request all the faculty members, just please wait for 5 minutes. The sir will join us shortly.
Hello, sir. Vikrant, sir. Vikrant, sir. Are you there, sir? Vikrant Vijay, sir. Sir, Vikrant, sir. Am I audible, sir?
Hello.
Sir. Sir, good evening, sir.
Welcome,
Am
sir.
I audible, sir?
Welcome, Vikrant Shitole, sir. Welcome. Yeah, you're audible. Thank you. Thank you for having me.
Okay.
What is
Thank
up?
you, sir.
What is up, everyone?
Thank you, faculty members, for waiting.
Thank you, sir. Thank you very much, sir, for joining. Sir, myself, Ashwini Kumar, Assistant Professor from Mechanical Engineering Department, Vikas College of Engineering and Technology, sir. Sir, first of all, I would like to introduce you, sir. Afterwards, I will hand over the session to you, sir.
Sure.
Thank you, sir. Yeah, good evening, dear participants. First of all, I will like to introduce today's speaker. His name is. Participants, please mute. Dear participants,
Miss Raga Kirtika ma'am, please be muted.
dear participants, please everyone mute. Okay, thank you. So today's now speaker is Mr. Vikrant Vijay Shitole. He is CEO of Thinkmates Edutech, Gen AI Transformation Advisor, and he's also a corporate trainer. And coming to his summary, Mr. Vikrant brings 18 plus years of global experience in analytics, AI, and business transformation across the manufacturing, BFSI, CPG, pharma, and IT services. His rare blend of ground level operational insight, leadership experience, and AI strategy expertise enables him to translate complex AI concepts into practical, business focused outcomes. A milestone in his entrepreneurial journey is co founding Homely, a platform for authentic home cooked meals that empowered 83 plus women home chefs and scaled across Mumbai. This experience shaped his deep expertise in customer insight, innovation, and technology driven solutions. Mr. Vikrant has held senior roles at NCDEX, Godrej Group, and Mahindra, leading high performance teams and large scale data programs. Today, he is one of the India's most impactful Gen AI corporate trainers, delivering the transformation workshops for leading enterprises including Adani Group, TVS Motors, JSW Infra, CDSL, and major pharma companies, NBFCs, IT services organizations, and academic institutions. His flagship program, Gen AI for functional teams, helps professionals master AI automation and no code tools and agentic workflows, enabling the organizations to reduce manual work by 40 to 50% and build AI ready talent for the future. His expertise areas are Gen AI automation and decision intelligence, agentic workflows and no-code AI solutions, applied analytics in marketing, strategy and finance, AI for functional domains, marketing, HR, finance, operations, strategy, and data storytelling and analytics thinking, corporate AI capability development. So this is the summary of today's streamed speaker. And Sir Vikrant sir, now I am hand over to the session to you, sir. Please carry on.
Thank you. Thank you, Ashwini sir. Thank you for such an elaborate introduction, and thanks for having me. Very honored and grateful that I got the invite to talk to such an august audience and a very, very experienced audience. He had a very elaborate introduction. Thanks for having that. My most important piece in that entire introduction is Homely, which I'm very, very proud of. I was a co-founder of a brand called Homely. Homely was a platform to access authentic home cooked meals from neighborhood, 5 kilometers vicinity. And we had scaled that startup to almost 470 meals per lunch basis across 5 years. We were live in 11 pin codes of Mumbai. So that's something I always highlight, apart from everything else. Very, very close to my heart, that startup. But that's been my background. Started my career in manufacturing. In fact, not many people know that I'm from mechanical engineering background. Started my career at Mahindra and Mahindra Automotive Division, so at a foundry product unit. So I guess most of you are from mechanical engineering background, or at least some of you. Ashwini sir is definitely from that department. So I can relate to the interjunction of where traditional branches of engineering, whether civil, mechanical, electrical, your mathematical modeling, and the technology in terms of data science and AI. So my expertise lies not just in the technology, but how well you can understand the business context, business problem, and explore that business problem into multiple angles before even attempting the solutioning. So, since I had a work experience across 5 major sectors, started in manufacturing at Mahindra. In Godrej Group, I was leading marketing and sales for a B2B industrial product called Godrej forklift trucks and warehousing equipment. Then in Godrej, I got an exposure to retail. My homely startup was in food tech. NCDX was in NBFC. So, having experience of 4, 5 sectors, I try to leverage that in my trainings, in my sessions, and hopefully we have 90 minutes together. Hopefully we'll add a lot of value over the period of 90 minutes. Feel free to ask me any questions, feel free to stop me. So I'm just going to share a few experiences, a few insights at my end, so that you, once we end the sessions, you take away few initial insights and few basics about how AI and Gen AI can be perceived, or probably a different angle of looking at Gen AI or AI ML for that matter. So that's my goal for today's session. So let me share my screen, and feel free to interrupt me. Feel free to ask me any questions. Let me share my screen. And I wanted this session to be very interactive. So I will be asking a lot of questions, and I want at least the chat box to be active. The best thing is if you can just unmute yourself and just say the answer, that will be the best. But at least I want the chat box to be active with your answers, right? So we'll start today's session. Today's is essentially AI and data science for optimizing energy consumption in urban infrastructure. Uh, we first will understand the world of business data and AI before actually going into the application part in energy consumption in urban infrastructure. And I'm going to demo live prompts. I'm going to give you a few magic hacks today. I'm going to show you and demonstrate live prompt engineering skills that you can take away, and probably not just implement as part of the construct of this session, but even in your personal and professional life. That's one skill, very, very effective in terms of communicating with AI is concerned. So firstly, everything that we do is in today's world dependent indirectly or directly on AI. So we order food on Swiggy. We basically communicate through WhatsApp, Instagram, Snapchat. Right now, I'm communicating through a virtual Microsoft Teams meeting. We do online shopping, Amazon, Zeptos of the world, Big Basket. We use Google Maps for navigation. We basically book a Rapido or a Uber cab. for getting from point A to point B. And even the smart watches, right? Nowadays we wear, everything is connected first to a data and then to a AI. So this is the world that we live in. Our 70% of our daily life is in a way, directly or indirectly, can be impacted by AI. It is fair to say that it is controlled by AI in some way or the other. So at least the 70% of our life today. All of you agree? Give a thumbs up. How many of you agree on this statement? Most of our daily routine somehow is so dependent on data and analytics, and that's where an AI comes in. Just give me a thumbs up emoji. How many of you agree on this? Excellent, excellent, superb. Second question, we are right now using Microsoft Teams virtual meeting link to communicate. Can anyone tell me per second how much quantum of data is getting consumed right now at this very moment? Anyone? So Microsoft Teams meeting with more than 2 members, a virtual meet, how much amount of data gets consumed if there are 4 members? Can anyone guess? And right now we are 277 members. So any wild guesses? I'm asking data consumption per second. Anyone? Anyone can make a wild guess? Anyone? You can put it in the chat box as well. Any guesses? How much data is getting consumed as we speak per second? Is it in megabytes? Is it in gigabytes? Is it in few MBs? Right? I got a one answer. Megabyte. If there are 3 people, per second 6.5 MB gets generated, consumed. Right? Now, if I want to basically understand per minute what is the data consumption, then 6.5 into 60 will give me per minute. If we are having a 90-minute session, then 6.5 into 60 into 90 will give me data consumption for 90 minutes session. But today we are effectively 278 people. So 278, the data consumption for that kind of a quantum of people, can anyone just ask ChatGPT and give me an answer? Even I don't know. So this quantum of this thing is minimum very, very close to 700, 800 megabytes per second. And you multiply that by 90 minutes into 60, 90 into 60 into 700 megabytes. And then that becomes a huge quantum of data, right? So every day we are generating lots and lots of data because everything is digitalized, right? We communicate, we order food, we navigate using data. In the process, what is happening is, for example, our car, not many of us know this, our car generates 300 petabytes of data in a single quarter. You understand petabytes? You're talking about megabytes, then gigabytes, then terabytes, then petabytes. 300 petabytes in 1 quarter in just 3 months. That's the data that our car is generating. So can you imagine the quantum of data all of us are generating every single second? It's massive, right? It's huge. Now, the entire game of analytics lies in how do you separate that 1 to 5% very, very important data from the noise. Only 1 to 5% of the data that we generate is really, really useful. It's worth millions of dollars. The 95% of data is just a noise, right? So the process of differentiating the useful data from that heap of data is called analytics. How do you separate signals from noise? That 95% unusable data, we call it noise, right? It's like finding a needle in a haystack. So if I want to find that 1 to 5% really, really useful data, I'll need to apply a process of analytics to essentially make sense of it. Otherwise, it's like what happened in Mumbai in 2005, floods, water everywhere, but not a drop to drink. So otherwise, data is everywhere, but very little data to make sense of it, make meaning of it, to convert that data into a financial outcome, very little data of that sort. The process of identifying and converting that 5% very useful data into meaningful insights is the process of analytics, right? Converting raw data into high quality decision. I repeat, converting raw data small d into a high quality decision big D, and that decision which generates business outcome in financial terms. Business outcome is only and only in financial terms, is analytics. So anyone ask you what is analytics, what is AI? It's very, very simple. It's a process of converting raw data into high quality decision. That decision should enable business outcome. Analytics has zero meaning if the data analysis doesn't generate into financial business outcome. So I was working for a firm called Mu Sigma. I was an account director. I was managing $4 million account, one of US's largest pulp and paper manufacturer called Georgia Pacific. And across their value chain, when I say right from procurement, marketing, sales, last mile delivery, logistics, supply chain, across their value chain, we used to do data science project. We used to leverage data, apply predictive modeling, apply statistical programming, and give them back high quality decisions, which in turn will generate business value. And across each project, I was leading a team of 63 data scientists, machine learning engineers, AI engineers, but I was only measured on the financial value that each of our projects generated. So the most important thing in analytics is raw data, small d, into a high quality decision and everything in between, which in turn should generate business outcome. So that is one takeaway I want you to take away. So someone in the chat box has put for 90 minutes per person, audio only 60 to 90 megabytes, video 450 to 600 megabytes, HD video 900 megabytes, almost a GB, and screen sharing plus video 1 to 1.5 GB. And that is only for a single person. Imagine the number of people that we have, and the data is already in terabytes, if not gigabytes, right? So that's what's happening live. So I mentioned that analytics is all about converting raw data into meaningful, actionable insights and then enabling the smart business decisions. You should convert data into business value and the financial value. Then only analytics has a meaning. So let's take an example, a very, very simple example. A lot of people basically understand data science and AI from a very different lens. So just a very simple example, just to understand how do you convert that raw data D into a decision, right? Let's say, imagine that I run a lemonade stand and I want to decide how much lemonade to make each day to avoid waste or shortages. So I run a small lemonade stand and I make a lemonade, especially during the summer month.
ये अभी तक नहीं बोल रहा था, अभी तो बोलना हो गया.
Yeah, thank you, sir. So especially if I want to calculate how much lemonade I need to make tomorrow, how do I do that? So I'm started a new business called Lemonade Seller, and a small stand I have. If I don't match the demand, what happens? If I make too lesser quantity, let's say I make 50 lemonade glasses and the demand is 200, then I'll be at an opportunity loss, right? I will leave money on the table. There was a demand, but I was not able to cater to. Vis-a-vis, if I make 120 glasses and only 50 people turn out, then I have 70 glasses, because lemonade is a perishable product, 70 glasses ka wastage. 70 glasses will go waste and I will burn money in the process. So how do I decide how much lemonade I should make each day to either avoid waste or to avoid shortage? So how do I do that? And how do I leverage AI and data for predicting it accurately? Any thought process? How do I do that? How do I solve this very, very simple problem? Any thought process? If I make too high a quantity, I'll be at a loss. If I make too little, I'm still at loss because I'll be losing money on the table in terms of opportunity loss. So how do I make the exact quantity? Any guesses? Anyone? How do I leverage analytics and data, and particularly AI, to make that prediction? So what I do is I first collect the raw data. Basically, the sales or a demand, I understand, can be heavily influenced by the weather patterns. On hot days, more number of glasses get sold. On rainy days or cold days, comparatively less number of glasses get sold. How do I confirm that? Because I leverage past 6 months data. To come to this conclusion, I read the sales data of a similar kind of a lemonade seller in for the last 6 months, and specifically for different seasons. What has his sales fluctuations based on the weather data? So I use the historic data. I take a weather reports. I take a weather prediction for next 15 days. And what I do is I also understand the customer preferences, particularly if there is feedback on particular flavors or sweetness levels. Someone likes sweet and sweet lemonade. Someone likes sweet and sour. So I basically take these kind of feedback as well. Then what I do is I essentially take customer feedback, I take weather reports, I take 6 months historic data of another seller to understand sales impact due to the weather. I put all these three data ingredients into a mixer grinder. Before putting it into a mixer grinder, I basically clean the data. Like if I want to make a fruit juice, I'll clean the fruit juice, I'll cut the fruits in a particular dimension before putting into mixer grinder. Similarly, if I want to make anything to do with this data, I first need to clean the data, pre-process the data, remove the null values, remove the duplicates, make the data ready for analysis. Then all three data set, basically I put into a mixer grinder. Mixer grinder I'm just using as a metaphor. That mixer grinder is nothing but a AI. AI model essentially identifies the patterns. What are the inherent patterns in that data? It identifies the sales increase if that outside temperature is 40 degrees Celsius. If the outside temperature is 34 degrees Celsius, what is the sales? It understands that historic data, it understands the pattern, and based on the predictive modeling, based on the mathematical modeling, with certain degree of accuracy, it will never predict 100%, but let's say it will predict that tomorrow, if Hyderabad's temperature is 38 degrees Celsius, with 92% of accuracy, you will have, let's say, 50% higher demand compared to today. That is AI driven prediction. That is what I meant by AI actually predicting what's going to be there for tomorrow. So this a simple example of converting a raw data into high quality decision, which in turn generates a financial outcome. The most important line I'll underline is the financial outcome. Why I'm saying again and again is because now AI has given me 92% confidence that today the demand will be 50% higher than yesterday because the outside temperature is 37 degrees Celsius. Yesterday, let's say I make 70 glasses. So today, 50% more demand, I need to at least make 105, 110 glasses. So it is suggesting me make around 100 to 110 lemonade for today based on the predicted demand. If I prepare just right the quantity, not just I'll be able to save cost on perished lemonade, but I'll be able to do a decent business. When the demand meets supply meets the demand, whenever the supply meets the demand, you are saving a lot of money. And in fact, you are making a lot of money. And this was a very simple example to understand data, raw data into decision into a financial business outcome. Data to decision and then financial business outcome. This process is called analytics. So anyone ask you in any space of event, what is analytics, what is AI? This is the most simple form of explaining what is really AI and what is data analytics all about. Analytics is all about converting raw data into high quality decision and decision which enables business outcome. So far with me, guys. Any questions so far? Simple enough. Any thoughts, any comments, any questions so far before I move on to next part? Anyone? You can put it on the chat box as well. Okay, let's move into the next part. And I'm going to ask you a few questions. So how can we do prediction in case where no existing data is available or we want to do something new? So what you need to do in that case is start generating data pipeline. Something, let's say, I am a company who wants to launch a new product in a new geography or a new technology I want to launch, which doesn't have a backdated data. So what I need to do is start from today, start today as a day zero and start building a data pipeline. Ensure which parameters you need for data analysis and start capturing those parameters from today for next 6 months at least, or next 12 months at least. Curate next 6 months, 12 months data where you become confident enough that you have large data set to basically put it into mixer grinder for prediction. So many situation happens in business where you don't have a data pipeline, you don't have a ready-made data pipeline. So what we suggest is first, either we will start making that data pipeline from today from scratch. We will ourselves engage and do the market research, or we will hire a market research agency who has done a research or a data analysis and collect data from them. So one way is to buy data directly if they have done a research in the past, or engage them to do the research from scratch to basically collect the data, build that data pipeline. And only when you have a sufficient data pipeline, you will be able to do the prediction from scratch. Otherwise, AI will not help you if you don't have the right data sources in place. Hope I've answered your question, sir. Excellent question, by the way. Thank you. Thank you for asking that. Great. So let me ask you a very fundamental question and let's go back to the history. Many people say data is the new oil, data is the new oil. And I'm a contrarian thinker. I'm gonna question that thought process. Is data really the new oil? Right? Is data really the new oil? I'm gonna question that. Everyone says, right? Data is the new oil. So let's understand it from a very different perspective. So what happened in history in 1850s, parts of America, Midlands America, Western America, Europe, parts of Western Australia, in 1850s, there was a gold revolution. Now, gold as a precious commodity has been there since thousands of years. Since 200 AD, gold has been very precious commodity because of high demand, low supply. What happened was suddenly some geographies in Australia, some geographies in Western Europe, and some geographies in Central America suddenly started digging their land parcels. And in the digging process, they were able to extract, some of them were able to extract gold. The process was very simple: mining, extraction, refinement. The process of basically digging up, mining is the process to identify where to extract. Then the process of extraction happen using tools, using equipments like shovels, and then you basically refine it. Refinement in case of gold is removing the other impurities and other alloys, because you will never find directly a gold directly, right? So if you want to refine this this thing, you need a refinement process to separate that 24 karat pure gold from the other alloys and impurities. The process was very simple: extraction, refinement, mining, extraction, and refinement. Now, my question to all of you: in this gold revolution, who benefited the most or who earned the most money? Can anyone tell? In this revolution of gold extraction, mining, and refinement, three processes, right? Mining, extraction, refinement. Who actually in the across the value chain earns the most? Who benefited the most? Can anyone share? There's no right or wrong. We are all learning. You can just put your thoughts. Dr. Amit Kumar said refinement. Are there any other answers? Who actually benefits or who earns the highest? So another user said mine owners. Okay. I want more answers.
I'm fine. Working well.
Actually, the people, yes, someone just gave an answer, equipment sellers. And that is the correct answer. Because people who actually manufacture the shovels, if you see here, people have hand tool equipment, right? It's a hand equipment called shovel, which is used for not just extraction, but even for mining and digging. The person who makes this shovel or the equipment sellers earn the highest amount of money. And the simple reason being very simple. Let's say three of us are there. I have 10 acres of land. I start digging, right? I don't find any gold. Then let's say Ashish sir has maybe just 5 acres of land. He starts digging. He also doesn't find any gold. But there is Sunil sir with just 900 square feet of land. He starts digging and he strikes a gold. Now, Sunil sir finds a gold, two of us don't find the gold. But who supplies the equipment that is shovel to all three of us? And based on the metric area, we basically put so many shovels at usage for digging, for mining, for extraction, for refinement. That person always wins. We may or may not find gold. The person who has given you shovel always and always makes money every transaction. So far with me, simple. So in a gold revolution, who makes the highest amount of money is the person who sells the equipment or shovels in this case. Any tool that is used for mining, extraction, refinement, these are the people who make highest amount of money because they make every transaction. You may or may not strike the gold, they will always make money. So far with me, if you agree, give a thumbs up. Excellent. Thank you. Thank you. Now we go 75 years ahead, right? We will go slightly ahead. 1850, say, we will go to 1945. And now in 1940s, what happened was Middle Eastern countries like Qatar, Dubai, UAE, Dubai, Saudi Arabia, Oman, all of them suddenly discovered that they had huge oil reserves and they had huge reserves of natural gas as well. So they suddenly discovered that they have huge reserves of oil and natural gas as well. Again, the same question I want to ask. Who benefited the most? Who made the highest amount of money? So in 1940s, the fortune of these Middle Eastern countries got changed because they discovered oil, they discovered natural gas. And if you see the process remains exactly same. There are three steps: mining, extraction, refinement. Mining, extraction, refinement. Right? And the answer is obviously someone just put right now the same machine suppliers. The people who supplied equipment to mine, people who supplied equipment to extraction, and people who supplied equipment to refinement are the people who made highest amount of money. And the logos that you see at the bottom, ExxonMobil from US, Shell from Netherlands and UK, and British Petroleum, as the name suggests, was from UK. They actually controlled almost 90% of the global oil revenues. In the process, and why did that happen? Okay, Middle Eastern countries discovered that they had oil reserves, but 200 countries actually attempted, including India, mining, extraction, refinement. Out of 200 countries, only 40 countries succeeded. Those 40 countries formed an association called OPEC, oil producing energy countries. So out of 200 countries, only 40 succeeded. But who supplied equipment to all the 200 countries who attempted mining, extraction, refinement are the logos that you see on the screen. So these companies always made money. Whether you discover oil or not, we will always make money in terms of providing you equipment. So because they had all the technology to extract. Middle Eastern countries like Saudi Arabia, UAE, Oman, they didn't have this technology. The technology came from Western countries. Now, in this revolution, the good part, and the earlier revolution, the gold revolution, the good part was at least the person who discovers gold or who strikes gold, or at least the country who actually finds oil, they also become rich. It's not just the equipment sellers who make money, they also make some money. So in countries like Qatar, UAE, suddenly it changed their fortune and they became rich, right? That is was a how in 18th century the revolution happened. That's how 19th century revolution happened. Now let's jump 75 years ahead. Today there is one more revolution happening. It's called Gen AI revolution, and the revolution has the same three processes: mining, extraction, refinement. I repeat, even this revolution has exactly same three processes: mining, extraction, refinement. And who makes highest amount of money? Yes, there are hardware providers also, I'm not listed there. They also make huge amount of money, like Nvidia and GPUs, people who actually provide them processing units to process large language models. Those also make highest amount of money. But all the logos that you see on the left hand side are making a huge money. So these are the people who supply equipment to mine the data, to extract the data, to refine the data, to convert that refined data into something useful. Something useful is nothing but high quality decision or a business outcome. Interestingly, we as India are the second highest producers of data in the world. Very soon we will surpass China. We basically have the second highest broadband connected users in the world. Overall, because of our population size, we produce highest amount of data. Very soon we'll surpass China. We are second highest today. And in spite of discovering that raw material which is consumed in this revolution, the raw material here is data. In gold revolution, the raw material was gold. Oil revolution, the raw material was oil. Here we are the second highest producers of this raw material, but we are not benefiting anything in this revolution. Are we benefiting as Indians? No. Who is benefiting at whose expense? We are giving them our data, and the companies or the logos that you see on the left hand side, unfortunately none of them are Indian, is actually making huge amount of money, right? Huge amount of money, billions of dollars. So I'll give an example. There's a company called Anthropic. How many of you know Anthropic? They have a LLM model called Claude. Every one of you know Gemini, every one of you know probably ChatGPT or DeepSeek or Grok. Very few might have heard about this company called Anthropic. Just raise a hand emoji or just give a thumbs up. How many of you know Anthropic? Anyone? So have you heard the large language model called Claude? Prashant has raised his hand, so he knows. Who else? So some of you definitely know this, right? Can you imagine in March 2025, Anthropic result basically announced it quarterly results. A single quarter in 3 months' time, Anthropic, which not many of us have even heard, has generated revenue of $2 billion, billion with a B, in just 3 months. How is it possible? So these companies are making a huge money based on our input, and that input is data. So interestingly, in AI revolution, unlike the gold revolution and the oil revolution we had in the past, the companies who or the countries who actually discover the raw material is not getting anything. So this is a ruthless evolution, right? Or entire pie of the money is taken by the equipment sellers. So far with me, it's a very different view of looking at the revolution, that journey that is happening. So far with me, do you agree? Give a thumbs up. Thank you. Thank you. So let's understand the history of AI. I know this is not part of this topic, but I just wanted to share this because it's very, very important to understand what is happening and how it is happening. So 1950, a seminal paper was written by a British mathematician called Professor Alan Turing. Now, Alan Turing, there is a movie called The Imitation Game. 2013, this movie got released, and it's a must-watch movie. Anyone who has a passion regarding AI analytics, it's a must-watch movie. So this movie is based on life of Professor Alan Turing. What happens is during the World War II, British military hires Professor Alan Turing to decode a German military communication code called Enigma. Right? So Enigma is a German military communication code. And to understand and decode that so that they get a basically upper edge in the war, they hire this Professor Alan Turing. Alan Turing, what he does is to decode this code, he makes a huge machine. The machine is almost 150 square feet. It's a huge machine. He uses cryptography, he uses mathematical encoding, decoding, so many other things he uses. And finally, he succeeds in decrypting or decoding that German military communication code called Enigma. The movie is all about that. Machine that he builds to decode many years later is called computer. IBM basically calls it as a mainframe computer. So that's how the computer engineering started. And he publishes a paper in 1950 called Can Machines Think? That white paper was the first time anyone had coined this thought process or even the term. So in 1956, the term came in AI, artificial intelligence. So he was also kind of a father of artificial intelligence that you know it today, because that was a starting point, even to get machine processor information. But for the first 50, 60 years, 1956, the word term AI was coined, but for first 50, 60 years, nothing happened. It was up and down, because only and only very, very niche, passionate people were doing research related to field of artificial intelligence. Not much money was poured by either the government or corporation. So if there is no money, then you will not attract the best talent. So very, very few hardcore enthusiasts, passionate people were focusing on research. In fact, in 1980s also, there was in IIT Madras, there was a PhD as early as 1970, late 1970s and 1980s, there was a PhD with a branch called artificial intelligence. So the word was not new. The science was not new. People were doing, but very, very few people were doing, unless until 1997, another historical milestone happened. So what happened was, in 1997, IBM's Deep Blue basically defeated Garry Kasparov. Deep Blue was nothing but a programming product. It was a computer beating Gary Kasparov, world #1 chess player. And that was a headlines in all the news. That essentially changed everything, how people looked at AI. Since 1997, this thing was noticed by everyone. Your venture capitalists, your big corporations, governments. From that point of onwards, huge amount of money started pouring in AI research, AI innovation, AI revolution. This was the start of what we call the AI revolution that what we see today. It started in 1956, but for the first 50 years, it was up and down. Nobody bothered till 1997, somewhere around here. If you notice, somewhere around here, and then the curve only went up, 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 and it's like a hockey stick. Then it was like so fast that I'm not listed the curve from 2023 to 2026 because then it's like a direct vertical takeoff. It's not even hockey stick, it's like zoom. What is the interesting thing here? If you see this curve, there is one interesting thing that I want you guys to take away. And that interesting thing is, if you notice, from 1956 to 2017, how many years? Almost 70 years, approximately almost 60 years, right? 60, 61 years. We only achieved this much as far as AI revolution was concerned. But since 2017, last 8-9 years, we have already achieved this much. First 70 years, 60 years, this much. Last 8 years, this much. And if you see the quantum, that 2017 was escape velocity for AI. Now it has like rocketed. Now what we are having is a hypersonic speed of AI revolution. Every third week, a new model gets launched, new technology gets launched, AI becomes smarter, smarter, smarter. What is scary in the process is we as humans are not ready for this speed of revolution. This is happening way too fast. Means anthropologists basically are telling in 2025, every 3 months was equal to 10 years of human evolution. So human mankind is progressing almost 10 years in every 3 months. That is the speed of AI revolution or tech revolution that is happening. And why this is scary is because we humans are not ready yet. We don't understand what is happening. We think that, okay, it's what a new technology. That's how computers got launched. That's how Web 2.0 got launched. That's how social media got launched. This is now something else. We will deal with it, but that's not the case. This is not that kind of a technology. This technology is far, far, far superior to the human intelligence that we have today. So November 30, 2022, ChatGPT got launched. It had an intelligence of a 9-year-old boy. In 3 months' time, ChatGPT made the intelligence level up to 19-year-old boy. By 2023, it had an intelligence of 21-year-old adult. Right? As on today, by end of 2023, it had intelligence of a PhD scholar. As on today, ChatGPT has an intelligence of a Nobel laureate of any subject. You put any subject, physics, chemistry, maths, computer science, engineering, mathematics, any subject on earth, it has a Nobel laureate level intelligence. That is the speed of how things are shaping up. And why I wanted to stress on this point is we have to understand we also live in the same world. And unless we match that speed, somehow we will be missing the bus. We will all, in whichever domain, whichever profession we are, we might miss the bus. So I request all of us to, whichever domain, whichever field we are in, to learn AI, because that is non-negotiable now. Because all of us think that we humans are using AI to get our outputs. That's one way of thinking, right? We humans using AI to get some outcome. Other way of looking at it is actually in the entire process, we are the product. We are getting consumed. The way we write prompts, AI learns from that prompts and becomes more intelligent. Every time I put a prompt, AI is leveraging my intelligence, my data, my reasoning, and becoming more intelligent. So every single second, so many prompts are written. So other way of looking at it is that we are a product and we are getting consumed. That's also one way of looking at it, right? We all think, okay, we are using AI. AI is a helpful assistant for us to achieve certain outcome. But if I flip the story, it's actually we are getting consumed. And not many people are realizing this. Or what speed mein aa raha hai, that speed, many people are just missing out. The speed is hypersonic. And not many of us are ready. So I didn't wanted to basically put this slide to scare people or to basically have a doomsday prediction, nothing like that. This slide is just to help you understand what is happening around us, and we live in the same world. We have to match that speed. That's all. If we don't match that speed, nobody's going to wait for us. That's also a harsh reality that all of us will need to accept. Great, awesome. So let's now dive into what can AI do. AI is nothing but interjunction of business, mathematics, and technology. Technology can be Python, technology can be ChatGPT, LLM models, anything. But I think if you really want to make a business sense from it, you need two other ingredients, right? Most of the engineering colleges teach programming, Python programming, they teach data science, they teach machine learning. But there are two other ingredients. One is how well you understand the business context. Because end of the day, your job as a data scientist or as an AI engineer is to not create dashboards, is to not create reports. Your job is to create a financial outcome. For that to happen, you need to understand the business context equally. And you also need to understand which mathematical model to apply in which context. That is equally important to learn and understand which mathematical model and which context will be the most important. So basically, I want you to leave and take this thought. Anything that needs improvement needs measurement. And wherever measurement is required, data will be always required. And wherever data is there, analytics and AI will be there. So like I mentioned in my first slide, 70% of our lives, we basically consume or generate data. We either consume data or we generate data. That 70% of our life is already directly or indirectly controlled, impacted by AI in some way or the other, right? So any corporation, any company will require improvement, because if they don't innovate in today's day and age, they will not survive. So innovation is survival mantra today, not to generate more profit, but to essentially survive. And for that improvement, you will need measurement. Measurement will always have opportunities for data analysis. And wherever data is there, AI will come into play. Right? So if I'll just skip this, the DIPP part of it, DIPP is nothing but analytics has multiple different ways of applying analytics. One is very basic descriptive analytics. Basically, you describe what is the data. So let's say I'm traveling from, let's say, Hyderabad to Mumbai, 700 kilometers journey. And whatever you see on my instrument cluster in a car, let's say I'm traveling from Hyderabad to Mumbai via car, all the things like speed, distance, fuel to empty, mileage, all of this is descriptive analytics. It describes what is the stage of the event as is basis. It describes as is the present. It will give you That's why it's called descriptive analytics. It will describe what is happening. You can even feed the past data and it will give you analysis of the past data. It will describe what that data is talking, what it is all about. Next comes inquisitive analytics. Inquisitive analytics is basically going one level above descriptive analytics by asking questions why, finding root causes. So, for example, why my mileage was only 13 kilometers in so and so stretch and my speed reduced from 120 to 90. I need to find the answers why, the root cause of this descriptive output. ये output तो आया, but क्यों आया? Is inquisitive analytics. Predictive analytics is nothing but leveraging past so many years data to predict something in future. So let's say between Hyderabad to Mumbai, I travel 500 kilometers from Hyderabad to Pune, and based on my 500 kilometers journey, whether my mileage, my speed, my gearing ratio, my fuel to empty, I predict the data from Pune to Bombay. That is nothing but prediction. That is in a very simple terms is prediction. Predictive analytics. Leverage past data to predict. And as a context of this example, what will be prescriptive analytics? Prescriptive analytics is nothing but recommendatory analytics. It's like doctor prescribes. So if I want to give a consulting report to someone, if I want to prescribe someone, that will become prescriptive analytics. And in that prescription, I will use all the modes of analytics. I'll use D, descriptive. I'll use I, inquisitive. I'll use P, predictive. Combination of all three, I'll prescribe. So for example, today I went from Hyderabad to Mumbai via car and I recorded my analysis. Tomorrow, if Ashish sir wants to travel the same journey from Hyderabad to Mumbai, I will give based on my experience today, I'll give him a prescription. Okay, the best journey is you start at 6:30 a.m. in the morning. You have to escape Hyderabad traffic before 8:30 a.m. You stop and so fuel pump. Don't stop in Solapur, stop in, let's say, Indapur. All these things is prescription. So road and Maharashtra border is dug up. So you need to take so diversion. All of this is like prescribing the other person what will be the best way of going from Hyderabad to Mumbai. This is what is DIPP journey in analytics. Basically, you describe the data, you find why, the root causes, you understand the predictive part, and you understand the prescriptive part. The same thing also applies in the context of today's topic. So if I want to basically apply this specifically from an energy conservation, specifically in terms of applications of Gen AI or AI for smart metering, for grid transformation, for energy conservation opportunities, then essentially I'll also follow the same DIPP route. And many companies have been able to do a lot of good work in terms of application of analytics or application of AI in across all the four fields. So for example, ABB is a company all of you know. They are into energy big time, and their energy monitoring systems gives you real-time dashboards on historical data to monitor energy consumption patterns across facilities. So let's say I have 7 manufacturing facilities all over India, and they give me a dashboard which is real time. I can exactly monitor this particular facility has 24 machines, how much each machine is consuming electricity or energy, and how much energy are we getting consumed. And then when we sum up at a facility level, they give a benchmark. And when I sum up at an India level across 7 facilities, they can give a value. This is nothing but real-time monitoring systems. Inquisitive analytics is basically fault analysis in electrical system, investigating the root causes. So there are a lot of IoT devices, IoT enabled monitoring systems across the spectrum. For example, identifying overheating in motors due to voltage fluctuations. That is another example of inquisitive analytics. Finding why, understanding why a certain value is beyond the norm. Predictive analytics also, so many AI implementations you see across the spectrum, monitoring which forecast potential equipment failures. We are calling this as predictive maintenance. Rather than waiting for some machine or a process to fail, we will predict beforehand, and we will do the maintenance based on that predictive maintenance rather than following a fixed schedule. Okay, every 15 days on a Sunday this machine needs maintenance. It's in the domain of predictive analytics. You basically predict the failure even before it can happen. And prescriptive analytics is end-to-end usage of D, descriptive analytics, end-to-end usage of I, inquisitive analytics, end-to-end usage of predictive. Combination of all three, I'll prepare a system which will now make recommendations for energy optimization across your manufacturing plants, buildings at a nation level. And automatically everything will adjust itself because I'm collecting real-time monitoring data. Data is real-time and make changes also real-time, very, very fast. Any questions so far? All of you have understood what is D, what is I, what is P, what is prescriptive, DIPP journey. Any questions on DIPP journey? And this slide essentially is to enable you to understand for our topic, if I have this DIPP lens, what is possible through analytics, what is possible to AI, ML. You can understand using the concept of DIPP. Descriptive analytics, inquisitive analytics, predictive and prescriptive. Any questions so far? Anyone? Before I jump into the next part. Any question? Okay. So this is my last slide and then we'll go directly into the demo part of it. I'm going to demo and write few prompts to demo how on a real-time basis you can leverage simple tools like ChatGPT or Gemini to create real output. Now, in terms of energy consumptions across urban infrastructure, there are so many things you can do, so many things you can unlock for basically implementing Gen AI or AI/ML to creating those business outcomes. So across the spectrum of energy and distribution, across the spectrum of building energy efficiency, transportation and mobility, urban infra and public utilities, smart city systems, sustainability, policy planning. There are so many other basically verticals where AI can create massive transformation. Because this industry is very nascent as far as implementation of data science and machine learning is concerned. So things like predictive maintenance of power plants and grids have been in effect in last 5 years, and the companies which are able to implement has seen a huge benefit. HVAC system energy optimization, predictive analytics for equipment energy usage, traffic flow optimization to reduce fuel consumption, smart street light energy optimization. That is happening in so many cities, right? In a tier 3 city, also in India, you can see smart street light energy optimization. A car goes and the street light will switch on or off. That is also happening, right? So a lot of people are designing interconnected system when we look at urban infrastructure, and that is where AI can make a massive difference. Because at the moment, nobody was really understanding or studying the data to make best use of it. Only when you study, make patterns, understand the data, then you will be able to apply predictive modeling. So last 3-4 years, many companies have started doing that. Many companies have started analyzing the data across the spectrum, and you will be able to see the outputs from that analysis in terms of, let's say, analyzing energy consumption trends for future infrastructure planning, for real-time fault monitoring, for real-time, even before anything happens, you can predict it, and you can basically prevent loss of life, loss of machines, loss of resources. That is happening purely through AI. And across spectrum, it is now getting deployed at a massive scale, and it is creating huge business outcomes for many companies. So before I go into the hands-on part, I just wanted to show you what used to happen is in companies, essentially, the problem statement is every company is hidden with vast amounts of sensor data produced by IoT networks. Uh, these are signals of unsupervised abnormal equipment behaviors that ultimately lead to unplanned downtime or decreased performance. And there is a complexity of HVAC systems that leads to device misconfiguration, like 40% of buildings making anomaly detection a challenge. So misconfiguration itself is almost 40% because the complexity of the modern HVAC system, that is the problem statement. And a lot of data that is getting captured, nobody is actually supervising it. Nobody is making sense out of it. So if I really want to do a real-time fault prediction, I want to prevent an accident. So how do I do that? So to build an anomaly detection, build something is different today, right? I'm having sensors across the facilities, across my plants, and I'm seeing on a dashboard whether it's voltage fluctuation, whether it's fault in particular AC unit or HVAC system. For me to basically act on it, I need to capture it real time, apply analytical models, and then basically see the patterns or anomalies within something happening. That is essentially the need of the hour. You should be able to do real-time fault monitoring, real-time fault prediction. As soon as you see the anomalies, okay, the voltage spike shouldn't have happened so much and this time, that is where the machine should be able to predict, because all of that effort, right? This is real-time fault prediction that happens, whether it's anomaly score, anomaly detection. Let's say in a HVAC system, I want to understand the compressor fan current consumption or fan current consumption. I understand the frequencies. I understand what is happening per second, per minute basis. But more importantly, I should be able to convert that data into immediate action. Because if I don't do that, if I don't, most of the companies have IoT sensors. Most of them are capturing this kind of a real-time data. If I don't do that, then I will be risking my employees to life-threatening incidents such as arc flashes. And these kind of incidents can be only and only reduced by implementation of AI for prediction. So for example, I'll show you a video. This is a typical maintenance going on in an electrical system, right? A typical maintenance going on, and suddenly the explosion happens. Luckily, that person survives this incident. But this happens because we are not able to monitor anything different wherever there is a electrical collision or flash incidents. There are so many signals before that. These signals we need to identify and ensure that we make immediate changes. And that is where Gen AI is making life much more simpler. The dashboards that you're seeing are being, the data is analyzed for real-time fault prediction and immediate action is being taken wherever any anomalies are detected, whether there is a current fluctuation, voltage fluctuation, compressor fan speed changing, immediately things are being actioned upon. So that is the huge change that you're seeing as far as implementation of AI in the real-time HVAC system or electrical maintenance operations is concerned. I just wanted to show you one case study, and let's now jump directly into demo. So because I promised you, you need to learn few skills before we end the session. So I want you to take away few skills which you can implement not just in your professional life, but also in your personal life. So let me stop sharing this. And the first thing I want basically to help you understand is how do I write prompts? How do I interact with LLMs to generate these kind of outputs, right? Without writing a single line of code, how can I extract maximum? How can I extract maximum from generative AI? So first thing first, what I'm doing is I want to do an analysis of a company called as Praj Industries. So I've written a prompt. I'm going to implement this prompt on LLM. Let me share my screen again. What I'm going to do is I'm going to ask a LLM, and this is a very, very powerful technique. I want you guys to pay attention. So can you see my screen? Just give it a thumbs up if you're able to see my screen. Okay.
Yes, sir. Yes, sir.
Thank you. Thank you. So what I've done is I have downloaded an annual report, a financial year 24-25 of Praj Industries. And I'm now writing a prompt. I'm writing a prompt. You are a McKinsey senior consultant. Now I'm defining a persona and a role for AI. And we want to present a strategy report to Praj Industries CEO Board of Directors. So Praj Industries is one of the companies in this space. Is the one of the companies in this space of smart electrification, urban infrastructure planning, though they are more into biofuels, ethanol production, but at an overall level, they are in this space. And it's one of the innovative company in this space. So I've chosen Praj Industries. And because it's a listed company, we can download their annual report. So I'm telling AI, you are a McKinsey senior consultant. We want to present a strategy report to Praj Industries CEO board. Given the attached corporate annual report, draft a strategy for how Praj can use AI and data analytics to optimize energy consumption in urban infrastructure project. Include executive summary, key challenges, strategic recommendations with metrics, implementation playbook plus time, risk and mitigation, and respond me in a structured format. So what I'm telling AI is, assume you are a McKinsey senior consultant. I'm going to give you a data. Data is nothing but a Praj Industries ka annual report. Based on this data and based on whatever you learn from the internet about Praj Industries, you give me a detailed strategy that I can present to the CEO. This strategy has to be a level of BCG or McKinsey. Means this cannot be just an academic student project, right? I want that report to be that level in terms of analysis. So I'm written a simple prompt, and let's see if I've been able to successfully extract that output from AI. It's just a 7-line prompt. The structure of the prompt is very simple. First, you define the persona. Second, you attach the document. Third, you tell AI what you want to do with it. And then define the output. Third thing is define the output, the way you want the output. Executive summary, key challenges, strategic recommendation, implementation playbook, and other things. So I'm gonna copy paste this. And let's see if I'm being able to generate that kind of a output. So let me close this presentation for that. Can you see I opened the chat GPT? I'll just copy paste here. I'll also attach this PDF. So because you will need to attach this PDF. Just a second. Let's first attach this. So this is Praj Industries annual report for 2024-25. It's almost a 70-page report. Let me show you this report. And based on this report, I'll generate a strategy report just by writing a 7-line prompt. I want to understand what opportunities as a Praj Industries we can have by leveraging AI in this domain of urban infrastructure and smart planning. So this is like a report. Almost how many pages is this? It's like a big report. It has a lot of financial statement, but it also has strategy. What worked for the company, what didn't work. It's more than 200 pages, right? 250 pages almost. So this report I'm uploading to ChatGPT and written a simple prompt. The report is uploaded. Let's upload the same report also in the Google Gemini and see which one gives the better output. So let me upload this even here. Just a second. And let me copy paste this prompt here. Same prompt, right? Enter here, enter here. This is just to show you how can you identify the opportunities for even starting, even before you start as a company, you can identify opportunities where GenAI can make huge difference. So as soon as I written this prompt, basically ChatGPT has started giving me a board of directors level report, a McKinsey level report for the CEO. AI and data analytics strategy for energy optimization. Which are the opportunities in urban infrastructure spectrum where Praj Industries can really make a difference? So it has given me an executive summary. So urban infrastructure, it has defined the verticals: wastewater, energy from waste, CBG, district utilities, green fuels, water system, is energy, entering an energy intensive growth phase. So we are a technology and EPC leader as Praj Industries. Energy efficiency is still largely engineered upfront, not dynamically optimized during operations. So we have a huge scope as far as AI implementation is concerned to harness that energy efficiency. So opportunity it has defined for us, what is the next opportunity and what kind of financial outcomes we can achieve. This is only by reading this one document of 259 pages. It has identified the key challenges, the current state diagnosis, right? Where are we struggling as on today? Structural energy inefficiencies in urban assets, fragmented data landscape. We don't have data which is under the single data lake, right? So it is given, we have SAP S4 HANA database, but everything is scattered. We don't have a synchronized database. So that's what the report says. EPC centric revenue model, increasing performance accountability. Third, strategic recommendations. What should Praj Industries do to build an AI driven energy intelligence layer? So what it needs to do, what core platform it can develop, use cases, why, what, and how, KPIs. Recommendation number 2, deploy digital twins for urban infrastructure. Which kind of digital twins, which location, everything it has given, right? Convert their product remote bridge into monetizable AI and O&M platform. So it is giving me multiple recommendation strategies, and it is giving me as a CEO what should be the implementation playbook and timeline. It's like a proper McKinsey report. All of you understand, right? How big four consulting companies give that kind of a report, and they charge a bomb, by the way. To generate this kind of a report, they charge massively for a company because this is directly action items. As a company, what you need to do to harness that level of financial impact. So finally, it has given a conclusion. AI-driven energy optimization is not an IT initiative. It is Praj's next structural advantage in urban infrastructure. Those who own operational intelligence will own the long-term value. Many people think that AI projects or AI-driven transformation projects are in the purview of IT in an organization. That's not. Essentially, this is basically AI transformation project comes under purview of strategy and CEO. CEO has to drive this kind of a project. Then only you will see the financial outcome. So this is almost a 7-page report by ChatGPT. Let's see what Google Gemini has been able to generate. Google Gemini has been also able to generate the similar report in terms of executive summary, in terms of key challenges that Praj Industries faces, strategic recommendations, digital twin for sustainable roads. Even ChatGPT recommended this. If you remember, predictive operations and maintenance using AI, implementation playbook and timeline. Right? What are the risks? What are the risk company faces? So these kind of output you can generate in minutes. I just wanted to demonstrate that. See how within minutes I was able to generate that. Let me show you one.
You are on mute, Mr. Mr. Vikrant, you are on mute.
Sir, please unmute, sir. Vikrant, sir.
Yeah, can you hear me now?
Yes, sir. Yes, sir. Please carry on, sir.
Okay. So since when I was unmuted, I didn't realize that.
Just couple of seconds before, that's
Just
all.
now.
Achha, just couple
Just
of
now, sir.
seconds, right?
Just now. Sir. No problem. Please carry on.
Thank you. Thank you for letting me know. So I was saying the companies in this space of urban infrastructure are all EPC companies. Generally, they get work through tenders. They apply to the tenders, government tenders, or large companies, private tenders as well. And essentially, they need to understand, even before applying to the tender, whether based on my past experience, is this tender viable for me to even apply? Because tendering process is a long process. I need to allocate a lot of resources. I need to allocate a lot of manpower, money, effort in even applying for a tender. So how do I determine whether so and so tender will be beneficial to me as a company? How do I even attempt that? Because unless I make that decision, uh, then I will not be able to give that much time and effort to even apply for that particular tender, because a lot of resources I need to deploy. Resources will have cost, their time, their energy will go into the tender. So generally, what used to happen in companies, so there used to be a marketing manager, there used to be operations head, the CEO, and other tendering people involved. They will form a team, they will come for a discussion, and they will take a human decision for this particular tender. Should we go ahead or not? Does this tender leverages our capabilities, our strengths and weaknesses, or does this tender we shouldn't apply because we don't have so and so eligibility, we don't fit the eligibility criteria? So these decisions were taken by a team, right, based on the past experiences. CEO will say, okay, this tender seems lucrative, but are we going to earn sufficient profit margin out of this tender? Operations person may say, okay, tender looks lucrative, but do we have sufficient manpower to execute that? Or will we find that right skills at a right time to execute that? All of that thing is essentially a decision making process. So how do I use prompting to make that decision whether even to bid for this tender or go for no bid? Bid, no bid decision, how do I make it using just prompt? So I'm going to show you a prompting technique to essentially make that decisions using LLM. So here, if you see in the green, I have written a prompt which is highlighted in the green in terms of you're an expert bid manager for Praj Industries. Uh, Praj Industries is a bioenergy technology, specifically in fuel ethanol. It's a leader, and in engineering solution, it is a leader in the market segment. You have a deep experience in engineering, process industries, and energy projects. I'm asking, read all the Praj industry related information from this company's website. So I'm setting the context. I'm defining a persona to AI. You will be given a full text of procurement tender related to energy, infrastructure, or sustainability. Carefully review the tender and help me understand it from a bid decision perspective. Whether should I bid for or not? But before giving me final recommendation, also identify all these things. Identify and list all quantitative requirements mentioned in the tender that are relevant to energy optimization, EV charging infrastructure, smart buildings, power grid optimization, energy storage. Why I've listed this all things is I want to understand whether tender is mentioning things like energy optimization, EV charging infrastructure, because these are my strengths. These are related to my company, right? This is how I find out whether I will be the best fit as a company for this tender or not. That's why I want to enlist this requirement. That's why I've written this prompt. Secondly, for each quantitative requirement, clearly mention what is the requirement is, numeric value in terms of kilowatt hour, number of units, voltage, timelines, where it appears in the tender. Tender is 200 pages long, right? I don't have time to go through all of it. A short explanation of context or the purpose, and based on the requirement, assess whether it aligns with our company's capabilities. Classify it across the following before saying yes or no decision. Don't directly give me yes or no bid recommendation. You see whether it aligns with existing EPC process engineering capabilities, whether we have sufficient EV charging infrastructure, Does it align with our smart building or AI-based building energy management system that we have? Does it align regarding grid optimization, smarter grids, or power distribution and intelligence, or energy storage or battery storage system? So we are under certain verticals. हमारे verticals में ये tender है कि नहीं? And based on that, give me a clear recommendation, bid or no bid, and support your recommendation with 3 concise reasoning. A technical fit. I want you to give technical fit. I want you to give commercial or risk execution risk, and third, data sensitivity in terms of IP exposure or strategic relevance. And then finally, list 5 practical actions the bid team should take in next 48 hours if this tender is pursued. Like if the ChatGPT recommends we need to pursue the tender, what is the next 5 action items we as a team from Praj Industries should take, right? This is the entire prompt. It's a very detailed prompt, but the idea is, now I have few tendering documents I've downloaded from few sites. Now, first tender I want to show you is IIT Palakkad tender document, right? It is inviting application from different players as far as EV charging system at Sahyadri campus is concerned. And it has all the things, rate contract, date of tender, everything, right? So generally this tender also is like multi-page tender. It will be at least 60-70 pages. If you see this document, this will be almost what, 30 pages here. This is a 30-page tender document. Now, I don't have time to read all of this tender document and see whether we are eligible as Praj Industries or not. हमारे पास इतना time नहीं है. Otherwise, I need to line by line understand each clause of tender and then decide whether we should apply or not. What I'm going to simply do is I'm going to apply, basically upload this tender on ChatGPT and see the magic happen. So let me upload this on Gemini first and copy paste this prompt which I just mentioned, right? So this is the prompt. You are an expert bid manager for so-and-so industry and help me with bid recommendation and next steps if we really want to bid it. So first, let me copy paste on Gemini and then I'll copy paste on ChatGPT and see the impact. This is the life skill. This is the life skill I wanted you to learn and take away from the workshop. That's why I'm doing demo. I didn't want it to be only theory, because this is hardcore skill. You can save huge amount of time. So let's see the response. The tender itself is 30-page document, right? I've not even read a single page or single line for that matter. I'm just using AI to not only understand the tender, and with help of AI, I'm going to make that decision whether should I apply for this tender, yes or no. Bidding, right? So it has given me an answer. As a bid manager for Praj, I have reviewed this tender. Quantitative requirements, I wanted it to list in multiple sections. So it has listed requirement, value and unit, location, context and purpose. So what is the requirement? DC fast charging capacity, AC charging capacity, input power specs, execution timeline, blah, blah, blah. It is given in a very structured output. Alignment with Praj Industries capabilities, right? Whether it's aligned. First point, no. Existing EPC process engineering, no. EV charging optimization, no. Smart buildings, AI energy management, no. Grid optimization, no. Energy storage, no. There is no requirement for battery storage in this tender. It is direct to grid charging system. So हमारे जो strengths है उसमें ये align नहीं है, वो clearly बता रहा. And bid recommendation, no bid. Reason, strategic misalignment, commercial scale. The estimated contract value is just 33 lakhs, significantly below a typical threshold for a global EPC player like Praj. That value doesn't justify the putting the investment in terms of effort. So technical fit, the tender specifies certain brands like Delta, Snyder, ABB. So Praj will act as a mere reseller, recontractor for this tender. So we don't recommend this to pursue this kind of a tender. If management decides to pursue this for strategic presence in premium institute like IIT, just for reputation, then do this. Do these 5 things if you still want to pursue it, right? So identify a partner, location check, electrical license verification, all of it. In minutes, I have not just decoded the entire tender. In minutes, I have a clear-cut action plan. Let me do it with ChatGPT with another tender. Same prompt, but here I'm going to upload a completely new tender. So there is one tender from Kerala government smart grid optimization tender. Let's see if this tender matches with Praj Industry ka this thing. So this is, if you see 85 pages, 85 page tender here, and I'm going to upload that along with the prompt. I'm not even seeing a single page, right? I want AI to read all of this. I'm going to upload this on ChatGPT and see if I can convert this into a go no go decision. Bidding karna hai ya no bid karna hai? Clear cut final recommendation. I attach the file. I basically then copy paste the same prompt saying that this one so file is attached. Last time I used Google Gemini, now I'm using ChatGPT. You are a bid manager for Praj Industries, blah, blah, blah. If this is what the document is all about, you need to see whether it aligns with my capability or not. Should I pursue this or not? Right? Enter. And let's see whether this tender matches our thing or not. So first it's decoding what this tender is all about, like summary, quantitative requirements, because that is what my prompt specifies. I want in this particular tabular output, and you see the tabular output, right? Requirement, numeric value, location, context, purpose. The entire tender is decoded in a very simple output format. What is the scope? Essentially, to understand scope of work, a lot of team members are involved to decode what is the scope of work, what tender says. This can be done in minutes, right? What is the requirement at every technical parameter? Energy optimization, smart grid functions, smart energy management controls. Even before giving a recommendation, it's just understanding the tender. Tender itself is so deep in terms of technical analysis and the requirement. So whatever is required, it is telling, and then it is telling capability alignment, assessment. Yes, no, yes, no. First, we have a partial capability. Second point, EV charging, EV optimization, no, we don't have capability. Smart building, AI energy management, limited capability. Grid optimization, limited. Right? This is a weak fitness with this tender with our capability is very weak. That's what it's saying. And bid, no bid recommendation, obviously it has given no bid. Don't waste your time in this tender. And this is the rationale. These are the 3 bullet points why we shouldn't apply for this tender. And exception, conditional interest. Only consider bid as a consortium technology partner if Praj contributes to energy optimization logic, so and so, or you tie up with BESS OEM manufacturer, battery manufacturer. Uske साथ partnership में you can apply, but don't apply otherwise. So if you think of applying or bidding, these are the next 5 action items you should take. If you still decide to apply, if you still decide to pursue as a partner, these are 5 action items you need to take. And there are other things which are missing or unclear. It has basically given as LLM has given what needs to be a next step. So final bid manager view, tender is technically sound but strategically misaligned for our company. So best course is no bid or limited participation via consortium. So this is how LLMs can be leveraged to make very, very immediate no go decision. And a complex document can be in minutes decoded. That is the power of AI. So that my last tool, I just wanted to, I know we are running out of time. Do we have 5 more minutes? Do we have 5 more minutes?
Yes, sir. Yes, sir. Yes, sir. Please carry on, sir.
So this is my last tool, Notebook LM. Very, very powerful tool. Now, though I am just demoing the tendering process or related to urban infrastructure, the same method can be applied for your academic use case. Same prompt can be applied for your own decision making as an institute or as an academician, researcher, facilitator. That's why I'm demoing. I want you to take up few skills which you can apply in your day-to-day processes. So what I'm going to do is I'm going to apply, basically upload the same tender here and see the magic happening. Just a second. Add a source. So let me upload this IIT Palakkad tender. This is a very powerful tool. One of the, in fact, the best tool. Just a second. Upload files. One of the best tool. If you really want to understand something very, very fast, I don't have time to go through 300 pages. I just want to understand what this document is all about. I just use Notebook LM. It's one of the most powerful tools, and I'm sure many of you already know it. Many of you must already used it. How many of you know this tool? Give a thumbs up. How many of you used this tool before? 1%, 2%, 3, 4, 5. But majority are probably seeing it for the first time. I'm just guessing. I don't know. So this tender of 30 pages, what I do is, if you see these tools on the right hand side, right? Very, very powerful. You can convert this tender into infographics. You can convert this tender into data table. You can convert this tender into slide deck or a PPT. You can, as an academician, these two functions are very important. You can convert any document into flashcards or quiz. Flashcards is very important, best form of understanding a particular concept. Or you can design a quiz. If you want to design a quiz on any topic, upload a document, click on this, a quiz, a ready-made quiz will be designed. There's something called as mind map. So mind map also I'm clicking. Then there's something called as report. I can create a CEO briefing document based on this tender. So briefing document, I click here and there is a prompt written by default. I just say create a comprehensive briefing document for the CEO of the company to make a decision post the analysis of the attached document. Right? The rest of the prompt, I keep it as it is. I don't change. Right? So in terms of executive summary, concise mein dena, body of the document must provide detailed and thorough examination of main themes, evidence, conclusions found in the sources. I just say ki I wanted for a CEO of a company to make a decision post the analysis of document. I click on generate. So this report is now getting generated. A mind map is also getting generated. Audio, you can generate a podcast using that PDF document. Isn't that very cool? Isn't that very, very cool? Right? You can generate a podcast just by asking AI to read the document. Or you can also generate a video. It's like a video made in 40 seconds. We as a humans will take a lot of time to read the document, create the PPT, create the deck, and just see the output, and then you will be mind blown how this tender has been converted into very, very powerful output. So some of the outputs are already ready. The rest of the output, if you see, they are generating, but some of the outputs are ready. For example, this infographics. So this tool has converted the tender into an infographics in just second. Can you see here? It's a 30 page tender, IIT Palakkad. 30 page ka tender hai. If I want to understand as a layman, using just one infographic, I can understand the entire tender. I don't need to read all the pages. I don't even need to read a single line. See what this tender is, why, what, and how. What is it all about? Project at glance. What is the tender? Estimated project value. 7 years service commitment. What is the commitment from the supplier? 4 requirements. 1, 2, 3, 4. Right? How to bid? That is given. Regional presence mandatory. If you understand, this is regarding charging station at IIT Palakkad. They want DC charger, fast charger, AC charger. So direct current, alternative current, fast charger. One very powerful infographics. I understand the entire tender. Isn't it so powerful to get the summary of any document? Isn't it powerful? In few seconds, I have just understood the entire complex tender. Just with just one go, right? Now, the other thing it has generated, let's see what else it has generated. It has generated a mind map, which is extremely powerful technique. So what it has done is it has read the 30-page document and it has basically split the data into structured indexing. So if I want to see tender overview, I just basically expand this and I understand at a high level what is the summary of tender. Estimated cost, monthly deposit, earnest monthly deposit, EMD is earnest monthly deposit, work location, scope of work, these 5 points, right? Technical specifications, these 3 points. Technical specifications can be also expanded like this. Eligibility criteria. What is the eligibility criteria for this tender? Critical dates, right? Post award recommendation requirements. All of it in matter of seconds. In matter of seconds, I was able to decode now the entire 30-page document. This is far more easier for me to understand. This I can use it for internal meetings to communicate with my CEO. Are you understanding? I've broken down a complex document in something easy to understand because of the mind map. This is how powerful storytelling can happen. I use mind map as a presentation tool. So I remember in my client presentation, no more I'm using PPTs. I once used mind map. Specifically, I just had half an hour to prepare for a presentation and I used this tool and basically that meeting went extremely well. So this is a very powerful storytelling tool as well. You should learn and implement whenever you have time. So this was mind map. What else it has done? So one document and so many things it has generated. It has also generated a tabular way of looking at the things. In table, if you want to see the entire this thing, you can see in a single row, technical specification, warranty, preferred makes, estimated cost, major items. It's like most important items it has picked up from the entire tender very fast. And lastly, it has also generated the briefing document. It is still generating the video and audio, but it has generated a briefing
we can
document.
download.
You can download.
Hello, sir. We
Yes,
can
yes, you
download
can
this
download.
one?
Yes, you
Okay,
can
okay.
download. You can download. So if you see here, there is a copy button, copy content with formatting and copy paste on your Word document. You can also download. I'll show you how to download. So this is briefing document for the CEO of a company. That's what the prompt was all about. Help me understand the tender in 2-3 pages. I don't want to see 30 pages. So if I want to send a report to my CEO, this so-and-so tender is a so-and-so this thing, then I can have a briefing document. Similarly, for you, in your context, let's say there is a research that needs to be done, research opportunity, and you need to send it to your senior management for approval. You can just create a briefing document for, let's say, director's approval or something like that, and send it. You can mail it directly, copy, paste, mail. So all the outputs can be downloaded. You just click the 3 dots and you click download here. You'll be able to download. So that's how things are there. That's how AI has evolved, and that's the world that we live in. So that's it from my side. I know I have exceeded the timeline, but I just didn't wanted this session to be theoretical. I wanted you to take away something from this session. So yeah, that's it from my side. Thank you for joining in. And any questions, I will be there for taking your questions.
Thank you very much, sir. Dear participants, if you have any queries, please ask.
Yeah, great insights. Maybe the first when you asked about whenever there is a evolution or any kind of whoever supplying the machines, they are benefiting most. being a big data provider, why India is not benefiting? How to get the benefit? I don't know whether it is relevant question or not, but how would we get benefited out of this? Because so far the history says everyone is benefiting, the gold miner, whoever. So how we need to get benefited out of this
We
as
have
an
to build
India?
our own. We have to build our own large language model, not depend on ChatGPT, Gemini, which I'm doing right now. We have to build our own large language model. So India AI program initiative by Government of India, they are actually building a India-centric, India-specific large language model. So there are 4 companies involved. Sarabhai AI is one of them, and they are building. They have started building it, which is very, very India-centric, Indie languages centric, that kind of a model. That's the only way we can compete. Till the time we don't have our own model, we have to depend on others, and others will take us for granted.
Thank you so much for that. Absolutely.
Thank you. Thank you. So thanks for asking that. That's a great question. So any other question? I saw somewhere in the chat that, and I'll tell you the live example, right? Whenever you see a tool like this performing and you might get skeptical and critical, such an important tender, can I really rely on the tool? We actually did it live for RBNCom. You can rely it. Obviously, there needs to be a human in the loop. You cannot rely 100% on AI, but you can rely 80% on AI. Put 20% your human decisions. You have human in the loop too. Whatever output AI has given, you also, that 1% basically validates as a human in the loop, but 80% let AI do the work. You have still saved 3 days of your time. Even if you just do 20% of work in tendering, 80% you have saved it. Forget about tendering also. I'll tell you, I use AI as a medical doctor. Can you imagine? I use AI as a medical doctor where life and death issue is there. Someone's life closest in my family is dependent on that answer. I use AI for decision making. Can you imagine? Why do I do that? Very simple. I'll give a live example. Let's say you go to a surgeon or an oncologist with 30 years experience. That surgeon or an oncologist must have performed in his entire lifespan maximum 1,000 surgeries. Right? Maximum. Human can utna hi kar sakta hai. AI, when I write a prompt to AI, I ask that AI to research not just India specific data points, right? I want it to research American Medical Journal, Japanese Medical Research Journal. I want it to learn data points from millions of surgeries and then come out with a decision or an answer. So then should I depend on a human doctor who has, with his 30 years of experience and 1,000 surgeries, or should I take a word of AI who is searching millions of data points across 7 continents? That is the difference. There is no right or wrong in this. I'm just sharing that I basically now can extract that level of output from AI, and I've started trusting decisions of AI in something very, very personal. So ये tender वगैरह तो कुछ भी नहीं है उसके सामने. You are understanding the point, what I'm trying to say. So that is the level of maturity of the AI models that has reached. You can beat and rely on them for something very, very where life and death is involved also. That is the power of AI, not just for professional use cases. So yeah, I want to leave you with that thought. Hopefully I made at least made you think more about the subject and intrigued you or made you curious to essentially read more and learn more about the subject.
Yeah, one point I observed, like for example, I attended an event, so and so a summit in 2025 by Telangana government.
Yes, sir.
It is quickly
Please go ahead.
giving insight. Maybe I don't know. Today, if I miss your class, maybe I with that title, if I mention that, will I get that inputs from what we discussed today? I don't know, but it was happened like whenever there was in a summit where I could not get the insights. Yeah, I'm asking ChatGPT what are the points discussed. It is quickly giving it.
Yes, yes, yes. That's a very good use case. It will give you in minutes, matter of minutes. And nowadays, whenever you go to attend seminars and conferences, what you need to do is you just have a recorder in the phone. Whenever someone is talking, you record that. You convert that into transcript, upload, ask your phone ChatGPT to decode the transcript and summarize in 5 lines. So entire 1 hour session in 5 lines, it will give you the gist. That's how you use AI. That's how you use AI for productivity. So yes, Ashish sir is saying everyone will get exposure to this till tools. Real value of human expertise will get lost. It is already getting lost, sir. We humans are just one cog in the wheel of the entire wheel, and next 5 to 6 years we have to make a difference in that entire journey. But if next 5 to 6 years we are not able to deliver that output, then we will be thrown out of that
Far
race
like
that we have created. So we will be
yeah,
overpowered.
one question now like see people who are everybody Gen Z all everybody is depending on ChatGPT, draft an email or whatever. But at some point of time, people are forgetting about while their thought process or anything like that.
Sorry, your voice got cut off in between, but I understand that because so many students and Gen Zs are using AI, maybe somewhere the human intelligence is going down, right? People are not using their intelligence, depending so heavily on AI.
Yeah,
And
absolutely. Maybe own creativity is missing. I mean, I cannot say creativity, but their thought process. Rather than they are just giving a good prompt where it will quickly throw these are the email draft what you are looking at. Then reading out and they are simply, rather than their thought process.
that is true.
Yeah,
That
that's
is
what
very,
the
very
worry
true.
all about.
That is absolutely true. I completely agree. But that is how the history says us, right? Of last 500 years, pehle, the human species were there. They were far more intelligent than us. If you see the temples, the architecture, the design, even Taj Mahal for that matter, our generation can never build that. Even with so many sophisticated tools and that we have, that level of human intelligence we can never match because as the human evolution happens, we will never be as intelligent as our past generation because of the tools. Tools will become more intelligent. We will become much more less intelligent. But that's how the human evolution has been happening. So I'll give an example. In 15th century, there was basically a gentleman called Galileo. So in Galileo, what he did was uh, just mapping the direction of sunlight hitting the earth and then the shadow length using calculus, using mathematics, accurately predict the movement of stars, planetary positions, earth revolution. Imagine the level of intelligence. No computer,
Yes.
no internet, no AI, no chat GPT, no even logarithmic tables. And to do that level of mathematics and actually predict that is far superior intelligence required. And at our level or our generation isn't able to match that. So if you notice, 19th century or 20th century was the last time when humans produced geniuses like Einstein. Uske baad there is no geniuses. That is the simple reason. Human intelligence will go down as the tools get more smarter, more better, and the history says us. So history is a kind of a
Yeah.
that's gonna happen, unfortunately. That's how the evolution happens.
True.
So yes, it's all hit and miss. The tool is there. It's how we use and how we use it for our context will be the key.
Dear participants, any more queries? Please ask.
Okay, so I'm also going to share LinkedIn, this thing, my LinkedIn handle on the chat. And essentially, you can reach out to me for anything. Case, because I understand this is today's a national level audience, right? They are from multiple states.
Yes, sir. Yes, sir.
So I'm just sharing my LinkedIn, and anything you want, you can get in touch with me. I'm not saying that I know many things about. I'm also a beginner and a learner like you. I'm just learning things. I'm in a very initial stage, but yes, with my experience across 4 different sectors and with little knowledge, we can create some outputs. So. Yes, all of you are absolutely right. We cannot depend 100% on AI. AI is just a tool, but AI is like a tool given free of cost as a Nobel laureate level intelligence to you. So if not making use of it is also the bad thing to do. So we should make a best use of it. If it's specifically free of cost, we should definitely. Done. Done, sir. Anything from my end?
Sir. No, sir. Anyone? Any queries? Okay, sir. Thank you very much, sir, for this truly rewarding session, sir. It's truly rewarding to reflect on the valuable insights, meaningful discussions, and collaborative learning sessions, sir. How AI will affect the humankind, and how it is effectively used in a daily routine. And it's very inspiring to see the real-time prompts like ChatGPT and Untitled Notebook. It's a very valuable session, sir. Thank you very much for your valuable time, sir. Thank you very much, sir. Thank you.
Thank you for
sir.
having me.
Thank you,
Thank
sir.
you. Have a great day. Bye. Good night.
Sure, sir. Thank you, sir. Good night, sir.
Thanks for having me.
Yes. Okay, dear participants, you can please, so that's all for today. And again, tomorrow at 6 p.m., another session will be there. Tomorrow also 2 sessions will be there. And we'll take all the queries today. And thank you very much, everyone, for staying up to this time. Okay, thank you very much. You can leave the meeting. Thank you.